we are not new in Riyadh. This is the third time we are coming to Riyadh. We were here in 2017, 2019, and now back again in 2022. In Saudi Arabia, this is our sixth edition. We've had, our fifth edition. We've had 2 events in Jeddah. We've had 2 events here, and this is the third edition over here. I'll quickly introduce the event series. So we started the event back in 2012. We finished around 107 editions in 34 countries, 33 countries currently around the world, with many more events planned in new countries. We've been talking about the new innovations in facade design and engineering all across these events. Domain experts who are architects, facade engineers, structural engineers, consultants and material suppliers have been talking across this event throughout the globe. I'd like to mention a few of them who are supporting today's event, starting with our presenting partner, Shuko. Shuko is a global leader in aluminum door, window, curtain wall systems. Our powered by partner is Guardian Glass, one of the leading coated glass manufacturers. Our associate partners, starting with Advanced Fiberglass Industries, who have some nice composites which can use for architectural applications. Sembrit is a fiber cement board manufacturer with some nice finishes. Cosentino is a Spanish company. They have a ceramic quartz-based cladding material. Dow is the previous name of Dow was Dow Corning. This is now part of the larger Dow Corporation. So it's Dow Building Science, the sealant and glazing division. FSS is a weatherproofing company out of Portugal. They have membranes and other products for curtain walls and facades. Equitone is another fiber cement board manufacturer with some nice finishes. Fischer is a German company into fixing solutions for doors, windows, facades, ventilated cladding. Future Architectural Glass or Future Group, they are a leading value-added glass processor out of the UAE. Hilti is innovative fixing tools, accessories manufacturer. Intertech is a testing and certification company. ISD Group, they have some interesting products for 3D facade engineering. Jotun, one of the world leaders in powder coating solutions for aluminum profiles, doors, windows, facades. Curare is the mother company of the laminated glass interlayers, Trocifol and Century Glass. Parklex Prodima is a Spanish company. They have an interesting timber-faced cladding product. Serge Ferrari is a French multinational which has fabrics which can also be used for architectural applications. Siderice are being represented here with their local partner, Fezico. Siderice have cavity barriers for curtain walls and ventilated facades. And our next partner is Technoform. Technoform has thermal insulation solutions in the form of polyamide strip and warm edge spacer bars for doors, windows, and facades. And our technology partner is Orga Data. So all the ones who have a green badge will have a USB stick hanging on your lanyard. So the USB is courtesy Orga Data. Orga Data have an estimation software for doors, windows, and facades. The USB stick has the brochures of all the exhibiting companies today over here. So we're not giving the bag anymore. So the USB stick has the brochures in a soft copy format of all our sponsors. I'll quickly run you through our next few events here in the region. We're doing our first event in Pakistan on 25th of January. Then we have Dubai in March. We've got Istanbul. And then we've got Egypt, Muscat, and we've got Egypt, Oman, and again Riyadh with Saudi Arabia next December. So these are the events we've been doing across the globe. We are planning to do in the next few months. Facades have become complex. They're no more straight glass boxes. They need to be engineered and need to be designed well. There's a lot of complexity now. People are looking at low carbon, sustainable solutions, safe solutions. So fire safety in facades is a big issue in this region. So they need an amount of engineering and need a little bit more attention than what they were being given earlier. So that's why these kind of events have been very successful for us across the globe. And I won't take too much of your time. I'd like to call upon today's event host and convener, Bart. He's the head of the KSA studio of Brewer Smith Brewer Gulf. He's going to be leading you today and will run you through today's agenda. So over to you, Bart.
Good morning, ladies and gentlemen. We're very happy to be the opening act, and I hope we can meet expectations after this great introduction, really. We will deviate a little bit, in fact, from the theme that had been originally introduced for us, because the client given us permission recently to actually talk about this. Therefore, we would like to focus on the project that you just mentioned, Bart, the Tadawul Tower, which is right up the road from here in King Abdullah Financial District. It's a very good coincidence that it's recently been completed, in fact. The client is happy to have us talk about it. It's, in terms of the theme of this being about facade design and avant-garde engineering, we think it's very appropriate, in fact, because even though the inception of the project predates the Vision 2030 and this new drive for quality and internationalization, the brief from the client back in the day has actually been, because it's a stock exchange, they wanted to be something very appropriate for them being the leading stock exchange in the Middle East. So they had given us expressly the challenge to create a building in terms of design and construction quality that could be in London or in Tokyo or in Singapore. And for the facade specifically, that meant, for example, floor-to-ceiling glazing, high transparency, but of course very energy efficient, LEED Gold rating, and no glare, very comfortable rooms. So the whole list of boxes all ticked, really. And I think now that the building is complete, we can say that we actually did that. And my colleague and the brains behind the design, Mr. Yamazaki, will go into that and how we achieved that with some ingenious facade engineering. And I think that that building will stand as a legacy of quality and the proof positive that this is possible in Saudi Arabia today, really, and one of the landmarks of quality engineering that will endure in the region. This is seen in the context if you would approach it. I think most of you will probably be familiar with the King Abdullah Financial District. Ours is this building. It's not the tallest one, it's this building right here. The top floors will be the actual stock exchange, and the parts below that will be a leasable office space. This is the location. It's one of the 5 sort of key towers that form the financial plaza, and the one that's most highly visible from the King Fahd Road on the east. Just a quick word, we're not trying to get too much into the general design of the tower, but the shape of it is not just driven by the theme of facades that KAFD had set. It's actually trying to morph a very highly efficient general leasable office floor plate on the back with a central core into a more perimeter-oriented floor space with an atrium, which is what the anchor tenant effectively, Tadawul, had requested. So there's an actual theme and a rationale behind the very dynamic appearance of the tower. This is just some general impression, recently taken photographs. And that leads to the geometry of the tower being so dynamic that depending on what angle you're looking at it from, it will be a very, very different dynamic appearance, and yet it is one of the highest efficiency floor plates that we'll find in the region, I think. It's just some further impressions. And without any further ado, I'll hand the presentation over to my colleague, Mr. Yamazaki, who is one of the design fellows in Henckens.
Hello, this is Yamazaki. I would like to explain the detail of the facade. This is in the screen. This is the photo of facade mock-up inspection. We carefully check the louver, mullion, transom, and the glass color. The tower surface is twisted. We broke up the glass by 1 meter pitch transom to minimize the deformation for cold vent. There are 2 types of facade, one for the tower and the other for the podium. The left photo shows the meeting part of them. These are the view to King Fahd Road through curtain wall. Mullion pitch is 1.5 meter to match to the office module. At the bottom, At the bottom face of the horizontal fin, you might notice wavy treatment. I will show the detail later. The view at the slit part of the office. The column shapes are special because of the building form. Typical office floor. Typical tower facade. Since the inclined column is moving at the office plan, the office module and the Marion location is also moving to follow it. Facade is inclined either outward or inward because of twisted shape. The detail of horizontal fin and transom, which is extended 250 millimeter from glass face at every 1 meter for shading. The section shows LED unit hidden between top and bottom part of the fin. The wavy surface at the bottom is to show the aspect of light and shadow. Usually this is very flat, but we would like to show some kind of texture on it. Transom's round section at the interior side that is around it, that remains continuous regardless of the tilt. The fin is tilt, but we don't want it to show how it tilts. Because of the round, it's always same for the inside. The transom round section at the interior side, that I already explained. The gradient of the fins always sloped outward, regardless of the inclination. One side is sloping out, the other side always sloping out. The top photo is the looking up view at the slit. The bottom one is close-up of horizontal fin showing the section. You can see the effect by wavy surface of the bottom of the fin. The drawings are inward inclined part. The south side fins are long triangle in plan, then the deeper in section. We designed the edge of the fin sharper than the other side in order to change the impression. These are the photos at the testing of the media facade. Indication of word and numbers, which means the resolution as a media screen, is the key to determine the distance of horizontal fins. The details of podium facade. Slit harmony at the tower and the podium. The north side of the 200-meter high tower is 5-meter cantilevered. This emphasizes sculptural impression and showing the entrance location. There is a north entrance for the car drop-off with canopy. At the northeast corner of the podium, a media screen of 200 millimeter pitched horizontal louver shape is installed, since this is the focal point of the district gate. The slit view at the interior and the exterior. The podium facade is designed to, the first, bounce the light reflected from the plaza into the forum. Then the forum is quite light. The second, minimize the view from or to the forum in order to unify both of them. Transom resisting wind rod is made of layered steel plates and cladded by stainless steel and suspended by a post-tensioned rod to minimize the vertical elements. Transom bottom face bounce the reflected light from plaza paving that I already explained, and it is very obvious in the photo. The facade at the plaza side is a composition of different scale of triangles to guide eyes to the entrance. The vestibule drum is supported by thick steel plate covered by a stainless steel sheet with minimum joint width. Exterior and interior view of podium entrance. You can see the minimum width of the stainless steel joint. Interior view at inclined mullions. Diagonal line gives us very strong impression. Joint at the plaza entrance. This is a very difficult part, very difficult work between the congested elements. So the worker did a lot of effort. And also our supervision team did so many struggle on it. The louvers at the roof represent star shape to express guiding star of Middle East economy. Each folded surface has different louver angles, and LED units are installed on them. The louver details at the roof. Rounded joint follows the different angles of louver. The louver pattern. It gives quite nice from the roof structure, but actually the space is mainly for the machines and also the skylights. So not people can go here and enjoy this. LED at the roof can show many types of lighting effect. We designed the facade not only for the exterior, but also for the interior design. This is a forum view. Facing to the plaza, we introduced the exterior into the interior. Interior design follows the district design code of faceted shape. Therefore, both come together harmoniously through the transparent facade. Forum view. The most complex part of the triangular facade at the plaza side. Reflection of inclined mullions, overlays on polished stone floor pattern. Office lobby view. Interior view at the meeting part of two facade system for the tower and the podium. I already introduced the exterior part. The interior view is like this. The bridge view at the forum, triangle facade form reflects on the polished stone on floor finish and creates impressive diamond shape. Stone wall of sky lobby, shown at the right, is tracing the exterior facade at the south. And the pattern of the roof louvers is matching with it. The concept is inside out and outside in to unify the facade and interior design. So what we always think is not only thinking exterior design, but also thinking or unifying everything into one total building design. Thank you very much.
Thank you.
Yeah. Yeah. Thank you so much. Thank you for the introduction. Good morning, everyone. I'm very happy to be here today with you in Riyadh. I have seen many familiar faces, so I hope that you will enjoy our presentation today. Okay, so first I wanted to take you through the environmental stewardship at Guardian Glass. Okay, so what's our approach to stewardship in Gulf Guard? And by the way, Gulf Guard is the name of our plant in Saudi Arabia. Okay, so for sure at Gulf Guard, we are committed to the resource efficiency as part of our stewardship vision. And for any of you who is wondering what's the stewardship, so the stewardship is our sustainability approach. So I wanted to take you through also what some of the initiatives we have been taken for the environment in our plant in Saudi, starting with the energy management, for example. So we were able to save more than 500,000 kilowatt hour per year by replacing the roofing system with LED, high efficiency LED fixtures. And also we were able to reduce more than 650,000 kilowatt hour by replacing the mechanical seals for our cooling water pumps. So this is when it comes to the energy management. For the raw material, so on average, we are using 15 to 25% of the cullet per batch globally. And the cullet is either the broken or the defect glass. Okay. And also another thing, which is the water and the wastewater. So we have reduced by 30% the usage of the potable water by recycling of the used water at the different processes. And for the waste management, we have reduction of 30% when it comes to the packing material by replacing the ordinary or the normal way of the packing by open boxes and then being shipped to our customers. And also I want to take this advantage to thank our customers for being part of this initiative. This is supporting for sure the society and the environment and saving a lot of the raw material. Also for the waste management, we have reduced by 25% the raw material losses during the different processes, such as the unloading, the mixing, and transportation by the optimization of the different processes. Okay, so now we will move to another part, which is the product transparency. So how Guardian Glass helps to contribute to the green building certifications. Okay, so starting with the energy saving products, for sure the glass performance has an indirect influence on the net primary energy results of the building. This is including the products that we are producing in our plants here locally, and also the products that being produced in our Europe facilities, since they are IGM certified to be used in our region, Africa, Middle East. Another thing which is the achieving the points and LEED or BREEAM or the different green building rating system. So we have published our EPDs and the PL for our products. And just for any of you who doesn't know, like what's the EPD, which is the Environmental Product Declaration, it is a document that communicates transparent and comparable information about the life cycle environmental impact of the product. And also for the product lens, which is another document that provides a material health assessment of using Guardian Glass float products. Okay, when it comes to the product performance, for sure the solar control or the thermal control glass can help to limit the high costs of air conditioning by minimizing the energy transmitted through the glass. And for the consulting part, like Guardian Glass and our lead experts always are happy to support you in your projects to gain like more points. All right, so how can advanced glazing help your project earn LEED points? So also like this is something in addition to our initiatives to the LEED and the US GBC, we are also part of the Energy Star, Federal Energy Star program. Okay, and this is something we are taking in consideration to support not only like the customers, but also the society. And for the LEED strategy, our products can help you to earn more points in 6 different categories, up to 42 points, generally speaking, in a program like the LEED. And this is supporting with the dedicated team members who are Green Building LEED associates. So we can for sure work with you from the early stage, either from design stage to see how we can collaborate together to gain the maximum points of the LEED. And also another initiative that we have taken, which is Guardian Glass for BIM. So we have developed a tool for BIM to help the architects and designers to understand the heat, how the heat is working in the building, and what's the effect of the heat from and the shades from the other buildings, and a lot of other solutions that we can offer. We can discuss it later on in our stand if anyone interested to know more about these. And for sure, the energy efficiency construction is indeed not only beneficial to the environment, but also to the society and the different businesses. And the top 3 environmental motivations, including reducing the energy consumption, lowering the green gas emissions, and improving the indoor air quality. So maybe some of you will be wondering how the advanced coatings can work to improve the indoor life of the occupants. So as you can see here, we have the sun. From the sun, we are mainly getting like two things, the light and the heat. So one of the main purposes of the different advanced coatings are to allow certain amount of the light to go through the glass. And another thing, to help to reflect the solar energy towards outside, and also to help to maintain the temperatures inside the room, either it's like in summer or in winter. And for sure, this helps like reduce both heating and cooling costs, as well as contributing towards achieving global recognized Green Building Program certification. So next slide, I will take you through some of our projects that is being LEED certified. So I will start with this, Sabiq Home of Innovation. So Sabiq Home of Innovation is the first home in Middle East and North Africa to be certified as a platinum LEED. The product used here is double silver coating. It's called SM30 or Super Neutral 30. And this coating offers a significant lower solar heat gain coefficient. It's like 0.1919%, and this indicates how well this coating can blocks the solar heat. And for sure, the lower the solar heat gain coefficient, the better the performance of the window or the glass. And this product achieved the needs, the architectural and aesthetic needs of the Sabiq Home of Innovation. And another thing, which is how this glass contributes to reduce the overall HVAC energy. So using this product, the Sabiq Home of Innovation were able to save 8% from the HVAC energy overall for the home. So I'm not sure if some of you maybe have seen the KSA pavilion, Saudi pavilion in Expo 2020. Also, this is proudly has used our product. It's LEED Platinum certified, and it was one of the best XL pavilions in Expo 2020. The product used here is Super Neutral 70. The glazing for sure helped achieve the aesthetic and the architectural needs of the pavilion by offering a high selective protection with a neutral looking from outside. This glass helped to maintain the temperatures inside the pavilion through the day. Another example, which is the Medina Airport, the new expansion. That was the first airport in North Africa and Middle East and outside of the USA to be certified the LEED Gold. If by chance any of you had the chance to see the airport during the day, you will not find like any artificial lights. And this is one of the main things about selecting the right glass. We wanted to reduce using, for example, the artificial lights, which can help us to reduce the energy consumption. The product used here is a single silver called Neutral 40. Which have like a combination of solar and thermal, good solar and thermal control. So another thing, which is the glass for innovation. I'm always like seeing the need for the development and getting like new ideas and producing new products that will satisfy the needs of you here, like from the architects, designers, developers, even to our customers as well and the end user. So for sure, I would like to start with the Science and Technology Center, which is our research and development center. So as we all know, there is no company to be successful without having a research and technology center for the innovation and the development of new products. So our Science and Technology Center, founded in 1999 in Carlton, Michigan, and it is the biggest when it comes to the research and development in the whole world for the glass. So here we have a story about Mariah Theater. It's one of the projects that I honestly love. I was there before, like with the old product from day one, and even some of my colleagues here, they were part of its success story. It started by understanding what's the need of the designer and the architect. Okay, so as you can see, it's a building that in the middle of the desert with very nice surrounding mountains. They wanted the building itself to be disappeared. Okay, and that was the main reason behind selecting that product. Even we have given a lot of options, but in the beginning they were rejecting everything. They said we wanted a mirror. Okay, we wanted the building not to be appearing at all. So we worked with the support of our plant here in Saudi and our technical team, with the support of our Science and Technology Center in the USA, to develop a product especially for Al-Ula. It's based on our ultra mirror solution, but something can be used externally. And the good thing that by the end of the project and all of the efforts everyone have given for that project, it has a Guinness Book record as the largest building in cladded with mirrors. Another part of the innovation, which is for sure the coatings on clear and also the trends. So for example, in the previous years, like the main thing for the coating for us and for the other manufacturers as well, to get the color is to use tinted or body tint glass. Okay, that has a lot of challenges. So we had worked for many years trying to make the products that will satisfy the need when it comes to the color, the performance, the appearance, but instead of using like the body tinted glass, to be used on clear glass. And I can say I'm very satisfied with the products, and I hope you as well, that we came up like during the past few years. We have made a lot of series, a lot of products based on clear substrate that helps to reduce the wastage, to have like a very short lead time when it comes to the production. Okay, and plus like it's even like better for the environment with less raw materials being used. So this is one part, coating on clear. Another thing, which is the trends. So for example, this is the photo that we can see here. It's one of the latest products that we have introduced recently. It's a grayish appearance. So the past few years we have heard from many architects, designers, that we wanted something with gray appearance and giving highlight transmission, and for sure to be comply with the Saudi building code. So we have the good thing, we are hearing you, we are listening you, and please keep getting us the feedback, because this is something we are taking in consideration. Based on that, we have made a product from the super neutral series. It's called SN Gray 50 with 46 light transmission, solar heat gain coefficient 0.25. And that was based on the feedback we got from you. And another important thing is not only the appearance from outside, but also the indoor appearance. So as you can see here, from outside, it's like neutral gray, but from inside, it's clear, transparent. And this is one of the beauty of having coatings on clear substrate. And also it has a high color rendering index. So this is like not, this is one of the latest products we have introduced, yes, but please stay tuned. We have a lot to announce soon. Having said that, I have reached to the end of my presentation. I hope that you enjoyed it, and thank you so much.
Thank you. Thank you very much. Can you hear me well? Great. All right. Good morning, everyone. Thank you, first of all, for organizing this event. Zak is always a very, very useful event, not just for connecting, but for technical topics. I'm really, really happy to be here. When I started thinking about talking about parametric and digitalization, I thought to bring something a little bit different than what is usually done. Parametric is nothing new in the engineering and architecture industry. It's been used for many years. What I thought is quite innovative in the way we apply parametric design is that we use it in very different projects for very different purposes and in very different stages of the design. And we're quite lucky to do that because we can reach the goal of parametric design, which is substantially, I like very much this definition, is to apply algorithm thinking and use the rules, the parameters that are set in the model itself to reach a certain design intent or a design response. We're quite lucky to do that because we have the chance to work in very different projects in different industries and in very different countries. And we thought to use that in what we call the one single model, which substantially means using all these parameters, data, FEA model, visual programming analysis, integrated with the BIM modeling. So to have one model, one source of information that is used by the entire design team and can be shared, especially with the multidiscipline or with the different trades involved in a design of a project. The purpose of this is to allow us to reduce the time to achieve a successful coordination and create as innovative solution as we can. So we've used it in many, many projects around the world and in many businesses or sectors where we're working, not only in facade engineering. What I have brought today is 4 case studies that I thought were representative for what is parametric design and how we can push further and what are the advantages we're bringing in the industry. So I will bring you a few examples of different stages, one for each one of these cases. The first one is in the very conceptual stage of the design when we are sketching solutions, when we are studying material and we're studying static scheme. And then we move into a more tender process, issuing documentation that is ready for the contractor to price a job. But the idea is to use parametric design. This is the traditional way of using it also in the later stage, and especially apply it in the benefits of the fabricators and the contractors. So during the preparation of contractors' production shop drawings, fabrication drawings, as well as during the actual site installation phases. The first case study that I brought is actually here in Saudi Arabia. It's the Experience Center in Neom. One of the challenges of this job was the fast-track nature of the project. We had to deliver in less than 2 months, basically a design that was ready to be tendered and priced by a contractor in the market. So one of the complex elements of this 3D form building, which is covering almost 200,000 square meters of built-up area, was the 16,000 square meters of the double curvature cladding element, which is made by ACP panels. So in a very, let's say, schematic point of view, what was done is that we introduced parametric model in the very beginning, when we got as an input basically a SketchUp model, so a mass model from the architecture team. This was translated in 2 main purposes for us, which were the study of the panelization to understand the geometry of this element, and then the study of the substructure behind. So in terms of paneling, the main topic was to understand the geometry of these panels, reduce or remove double curvature, and study in order to reduce the number of singularities and the typologies within the panelization. Whereas for the substructure, substantially the input was to generate a wireframe that will be supported behind the panels themselves and follow the geometry. And the output was gained back to the design team, so basically the architecture team, with an output that was effectively a BIM model that could be used for the integration with the rest of the discipline. So this was the real advantage of introducing a parametric tool in the concept basically stage of this project. And as an output, we were able then to generate in the most automatic way the typical documents that are required for pricing a job. So bill of quantities, drawings, a BIM model, even reports were extracted automatically out of a Grasshopper platform. And of course, they were then integrated with the rest of documentations like specifications or 3D prototypes built by hand. And this video is just a sample of how a simple parameter like the dimension, the width and the height of a panel can be set inside the model and can be used then to study many options, and is then post-processed into the next step of the design, which is of course the substructure behind. And this is used then to, as you can see, to generate a wireframe that is exported inside the calculation model. So everything, like I was saying before, is inside one single entity. The analysis is run, is returned back into the Grasshopper, that is then used to export material takeoff for the bill of quantities. If this was a very, very initial stage, so we were in a schematic concept in the cruise terminal in Dubai Harbor, we had the chance to do, let's say, a full design up to IFC, and the elements where the usage of these tools was very useful was this facade that is covering most of the 13,000 square meter area of the building, and it's made of basically standing seam covered by a shingle system. The idea was to model the entire build-up of the facade and the roofing itself, which has this diamond basically shape, in a parametric model, so that we could study many options together with the architecture team, understand where would be the constraint in terms of the fabrications for these elements, and also have the chance to study very special topics like the patterning of the color. This distribution of the RAL in this facade seems random. It's effectively not random. It looks random, but it's governed by an algorithm which was imported, set inside the Grasshopper script, and was basically run many times till we had the satisfaction and the agreement of the client and the rest of the design team. So basically we followed a similar process as the one that I explained you before. So we started modeling the main elements of our roof and our facade. So we have steel structure, we have the typical built-up for a standing seam roofing, and then we have our shingles, which are typical elements of 1.5 by 0.5 500 millimeter dimension. And again, the starting point was a mass, was a volume model, 3D model in SketchUp. This was converted into a initial wireframe model for the entire steel structure, which was, of course, the starting point for our geometry. And then this was generated also for the unroll of the skin, so the generation of this pattern of ACP cladding covering the roof and the facade. And like I said, all the studies that were done related to the fabrication, and also, for example, the RAL distribution, were done inside this geometry, inside this platform in Grasshopper. And then finally, as an output, again, we could export everything in Revit so that the rest of the team could be working with the same environment that they used and they're familiar with. And the generation then of the rest of the documentation at the end of the IFC design was quite straightforward after this. We jump then into the other two stages, which starts from the fabrication and then to the site, to the actual execution of the job. This is where I find that it's parametric or digital tools are less utilized in the market. We had the chance to do it in this project in New York City, because despite the size of the job was not that big, there was a very complicated stone cladding facade with natural stone, covering less than 2,000 square meters, but again, very complex to execute. So the idea we had in mind was to try to improve as much as possible the feasibility for this cladding, reducing, of course, the cost for the execution, and standardize the elements, still following the complexity of the surface that was included basically in the initial renderings. So the digital tools or the parametric model was applied to all the elements that were composing our facade, and they were starting from they were basically embedded inside the shotcrete main structure, and we had let's say a thermal insulation layer, then the steel substructure, which I will show you later on, and then of course the stone cladding, 5 millimeter thickness. So the structure itself was already quite complicated, but seeing a single panel would not give the real idea of the complexity of the building. And the four main aspects to be governed were the shape of and the curvature, especially of these elements, the necessity to have a certain number of connections for the stone cladding fixations, the embeds that were governed by the surface of the shotcrete behind, so the main structure, and then the interface with the window or vision elements. So with these four, let's say, main restraints in mind, we started thinking that, and we were working for the fabricator in this case, we started thinking that we could be applying typical parametric or digital modeling after a PCSA exercise, which, like I said, is not a very standard approach, and then use that for the generation of the fabrication model. So the way this was done, it's basically we got as an input the study of the stone geometry and the geometry of the main structure behind. So we had two surfaces to be followed, and we took on board the PCSA done by our client, by the fabricator, and the geometry constraints which were given by the stone manufacturer and consultant. And these were used to create a huge parametric model, which I'll show you later on, which was then set as an input for the fabrication stage. And only once all the parameters inside the digital model, the parametric model, were basically green, were thick, we were able then to move into the next stage in the fabrication. So as an input to this is basically what we got, and we started creating this grasshopper model, and we had two main items. One was the geometry of the stone. There were certain restraints related to the thicknesses, the volumes, the weights of the stone panels that we had to respect, and the other one was the generation of the wireframe for the substructure behind. So I just put a video which is showing some of the controls that were applied on the stone geometry. So the starting point was a spreadsheet, basically, with certain rules to be guaranteed for the stone. This was imported as a script inside Grasshopper, and once the script is applied on the model, you can see graphically in the Rhino interface that any non-compliance is detected. In this case, for example, the weight of the single panel, or it could be the dimension of the panel, the dimensions of the joints, and so on. So all these non-compliances are highlighted in the model in the very beginning before we proceed with any actually engineering activity. And once the surface is sufficiently, let's say, clear, we start into checking other aspects like the horizontal joints. We generate a first trial of stone with flat surfaces. We create the connection with the extrusions behind, and we adjust the surface of the stone along the edges to guarantee the interface with the window wall system. Once this is done, we have basically created a new stone geometry which is fully compliant, just out of a click in the model. It's fully compliant with the geometry, and we can apply other types of let's say digital tools as we wish. So for example, we have applied the codification of the stone panels, we have applied the false joints along the surfaces. So the model is substantially ready for the stone itself, is ready to go then to the next step. And the next step is, like we were saying, the control of the steel structure, which is also done out of a certain number of parameter and control. So we can move, like I said, into the geometry of the substructure. We can check and apply changes in the stone joints to fit the substructure design. And this again is a quick video to show you let's say the complexity of the substructure behind and how these necessarily have to be adapted once we have applied certain modifications on the stone. And of course, this can be done manually. There's nothing wrong with that, but the idea to implement this in an automatic manner allowed us to study more options and also to optimize the time in our execution. So in the Grasshopper interface here, you can see that the geometry of the script is already updating our mullions, our vertical elements, once we have imported the new stone geometry that I mentioned before. And then, of course, the adaptation can be applied to any other components of the model. This, of course, is a huge model. So, for example, for the comps or let's say the intermediate transoms, they can also be adjusted manually based on the preferences, for example, from the fabrication point of view or based on input from engineering. And the cut lines inside the mullions are updated automatically to match the new position of the transom themselves, of the comps. And once this is done, the geometry is effectively fully compliant for the main steel elements, and we are able to move into the next component. Actually, we can create already the Rhino model, which will be important for the engineering. So we are creating a wireframe out of this parametric model, and we bake basically all these elements so that we have a final model including all the mullions and transoms. The last two components are the anchoring point for the stone fixation, with, of course, different typologies which were tried to be standardized as much as possible. And here the main, let's say the main difficulty was how to manage the differences in the geometry, and especially in the gap between certain areas and different areas, the gap between the stone panel and the vertical elements. So considering also the regulation tolerances and the fabrication tolerance that were provided by the fabricator, we had set a certain number of points that were geometrically controlling basically these elements. So these embeds are not done manually. They are controlled by a certain number of points substantially, and by varying the position of these points, we're able to change, for example, the location of the embeds. If, for example, the distance between the stone face and the vertical mullion is too high. And again, once this is done, the modification inside the Grasshopper model is applied also to the vertical mullions. And so, for example, the holes for the fixation inside the fins are updated automatically. The last point that is then pending from here is doing some further automatic check related to the general geometry of the model. Of course, when we manipulate so complex and big parametric model, we need to have certain number of checks along the way. And this can be iterated many times, like I said before. So if there's the intention to change for some reasons the geometry of the surface of the stone, this can be done. And finally, the last point is applied on the embeds on the concrete. Like we said, the surface of the concrete was fixed from the structural designer. So on the embeds are somehow the easiest part. They have a very ununiform condition, but they are not governed by any specific design or fabrication requirements. So in this case, it's just an output coming out of the rest of the modeling activities. And in this way, we are substantially creating a model that is ready to go for the fabrication, for the contractor. So the whole idea was to bridge some of the steps that are usually carried out with let's say with traditional design approach without a parametric model. And of course, the last step, not least, we do engineering checks. So the wireframe that was built in the previous stages is ready to be imported in a commercial FEA software analysis. This is the wireframe still coming out of the Rhino model. It's imported inside, in this case, SAP 2000 software. And the model is actually already built with everything in place. So even loading conditions, restraint conditions, boundary conditions are already modeled inside the model. So substantially, the user just have to save the model, bake the model itself, open the model with the commercial software that was chosen. In this case, it's actually Strand 7. And you can see the model is ready to be run. And the rest is just engineering check, of course, in case of any deficiency or any issue that is identified, any overstressed element. We go back inside the Grasshopper model, we modify accordingly, and we run again in a iterative process. That's about it for the steel substructure. And then, of course, the last portion that is quite straightforward is the generation of the fabrication model. So the output is quite simple. So we have decided to move into a different software, which we felt was more, let's say, appropriate for the fabrication part, and we were able to generate assembly and installation drawings automatically from here. So we saved a lot of time in the late stage of the design. The last example that I brought is the Cultural Center in Education City in Doha. This project is not yet complete, it's under construction now. And it's also a very challenging job for its roofing surface with this quite big, it's almost 6,000 square meters of roof area with highly complex double curvature surface. And one of the biggest component and complexities of this job is that in the central portion of the roof, we have more than 6,000 skylight cones, which are used for the generation of basic natural light inside the building. And these cones are spaced at average spacing between 600 to 700 millimeters. So they're very dense, and this creates a lot of, let's say, obstruction for the structure and for the build-up of the roof. So again, the idea was to try to create a solution that will work in the geometrical point of view. We were very concerned about the possibility to overcome all these restraints and being effectively able to pass through all these cones. So we had first, after, of course, a first initial study related to material solutions, and after having chosen the build-up for the roof, we decided to build components inside the parametric model, which were representing the primary structure, the purlins, the sandwich panel, inclusive already of, let's say, prefabricated with the holes already, and then, of course, whatever was coming on top, that was basically a mortar bed where the tiles were embedded as the last step. And then the skylight cones were prefabricated and installed from underneath prior to the installation of the ceiling. With a similar, let's say, process, as I explained you before, having as an input an architectural roof geometry and the position of the skylight cones from the architectural team, we decided to start immediately creating this wireframe in a Grasshopper platform, and to use this wireframe then for the entire engineering check, of course carrying out then clash check along the entire roofing. Once the clash check was passed successfully, we will be going into a, let's say, the output stage that I explained you earlier. So we will work in a Revit environment, and we will generate all the typical outputs that are required for an IFC stage. So from this geometry, basically what we started thinking was which type of wireframe is able to guarantee which type of structure can run through these cones. And the best geometry that was thought was basically a triangular wireframe. And the first thing that was set inside the parametric model was basically a volume, so a surface, a box where the steel structure could pass. And this volume was generated so that we wouldn't have to worry about cones anymore in the rest of the design process. We had these boundary cones. We were not allowed, due to a parametric check, to go outside this boundary. And these boundaries were also considering fabrication and installation tolerances. So again, the steel structure that was coming out of this analysis was basically ready for the final step. And I'm almost done. So the clash check was then carried out, and once turned out to be successfully, we were able to move back into the last step, which was the generation of effectively the final surface of our elements. These profiles are extremely complicated. They are all built-up sections. They're all unique because they have to pass through these myriads of skylight cones. And however, as you can see, as the results of the analysis, they are able to guarantee effectively a completely crash-free model, and they guarantee the thickness, the depth of the roof that was imposed. But as you can see, when you go towards the edge of the building, is narrowing down to less than 300 millimeter. And so basically with few, let's say, macro parameters inside the parametric model, we were then able to reach a final goal in the engineering and in the geometrical point of view. And this is then the source of our output, which is, let's say, one platform governed by a Revit model, which is used to generate the full set of drawings, the material takeoff, and of course, all the documentation. And on top of it, this was also done for exporting a pre-camber model. This was something that was not planned initially, but it was very soon realized that the number and the position of these cleats will be very critical for the fabrication due to the temporary stages and the pre-cambering imposed to the main structure. So the same basically parametric model was also applied on the pre-camber geometry. So we were able to effectively deliver to the contractor a model that was ready for fabrication, including the pre-cambering or the presets. And that's my last slide. Thank you.
Thank you very much for the introduction. So thank you again for the introduction. It's a pleasure to be here in Riyadh today. Very nice presentations for my previous colleagues. Congratulations, Giovanni, very nice presentation. Zak, it's always a pleasure to be with Zak and with the facade reference people. Some new faces, some old faces, so thank you for being here today. So as previous I was presented, my name is Paulo, and today I'll be delivering a presentation about the future-proofing your project with 8.1 fire-rated weatherproofing solutions. So FIS is a worldwide global brand. We are experts in weatherproofing solutions, and within weatherproofing solutions, we have different kinds of systems. We have breather membrane systems, vapor control layers, we We are experts on EPDM, and we are able to customize solutions according with each need of each product, bespoke solutions. For us, product is only a product, but for us, understanding the needs of the customers is very important. So a big part of our work is working very closely with each customer and each project and understand the needs of each product. From there, we are able to develop solutions that are completely customized for each market and for each customer. I'm bringing this topic, and I brought this topic in other presentations of Zak, because I think we should reflect about a very important issue, that is fire. That is something that is a big, big problem, and it's a global problem. It's not a problem that happens in Europe, or only in Middle East, or in a particular area. No, it's a worldwide problem. And we see this in Europe, we see this in UK, we see this in Middle East. We saw this, for instance, in UK, in Greenfield, everyone knows, but also we see this in Dubai, or we see this here in Saudi. So I think it's a very important topic in the facades, and somehow we should reflect about this. Following this big problem, this huge problem that continues, unfortunately, and that's why I'm bringing the topic again, the authorities issue, I'm sorry, can I go back, please? I'm sorry for that. So I was saying that authorities from the different regions, the different countries, they issue regulation to overcome, to solve these problems. So for instance, I brought some examples of regulations developed in the Middle East. Specifically, I brought the Dubai safety code, but also in UK or Europe, the authorities, they issue new regulations to overcome this problem. And they advise, for instance, in particular, the weatherproofing solutions, vapor membranes, that should be used A1 fire-rated solutions. Or in small areas, it can be used, for instance, B. So, because this is a very big issue, and it's a problem that it's related with human life, with liabilities, it's a responsibility of all agents that are somehow involved in the facade. So it's a responsibility for all of us, all of the facade agents, construction companies, consultants, architects, that have the power of decision. And we should do what is in our power to overcome and to choose the right solutions to overcome this problem. For the last 12 years, we are working to develop solutions that can fulfill, that can deliver products and solutions and systems that overcome this problem. So we were listening the needs of the market, and we are speaking with consultants, universities, with our industrial partners, and we were able, and we are very happy because we were able to develop solutions that fulfill and comply with these requirements. So we developed a technology that complies with A1 fire rated and A2 as a system. And these systems can be used internal or external, depending on the climate, depend of the area. If you are using them in the Middle East climate, or if you are using in the Europe climate, so we can adapt. And we have breather systems or vapor systems that they are vapor control layers, or they are breathable membranes, and both the systems, they are A2 fire-rated systems. Of course, that is very important that we have the systems completed, tested, and we have them also approved and also installed. So this is not theoretical, this is practical. So another thing that is very important, and people that is here, that are experts and professionals in facades know that a product is only a product. So we need a completely system, and we need accessories to warranty us that we can apply these solutions in the different substrates in connections with different elements of the facade. So we not only have the membranes, but also we have the accessories that allow us to customize the solution to each project. For instance, we see here some brackets, some penetrations, and we have the specific solutions, the specific accessories for these specific particular situations. Here, for instance, we see our vapor control layer systems, and we can see the details, how we seal the penetrations, the cables, pipe penetrations. Usually what happens in the facade is the problems come from the details. And we are very keen in the details. We like the details. We treat very particular each detail. And of course, the system is tested, and it's important that it is tested under the 13501. So as we can see here, we have both systems tested with all the accessories. This is a third-part testing. Also, we test the system in the AN 13501, but also ISTM. And here we can see that also on the ISTM, we reach very good results on the test resulting. So on the breather FER membrane, achieve 5 in a range of 0.25 to have the class A. And in smoke development index 15 for the class A. Vapor, it's 0.0, so it's a completely the best that we can achieve. And of course that we have third-party certifications. So for each market, each region, we have specific testing, and we have specific third-party certifications for the Middle East, for Europe, for UK. Of course that solutions and tests are very important, but more than that is when we have the experience. And I brought some examples, worldwide examples, Europe, Middle East, UK, US, where we applied our solutions, where we apply our systems. That's why it's not theoretical, and that's why I'm saying that each of us that has responsibilities should choose the right solutions, and we have solutions that can comply what are according with the requirements of each region and each market and each project. I brought here some example of AVCL membrane, some considerations, because AVCL, it's a product that does not allow the air to flow from the outside, hot air, to the inside. It's a vapor tight, and in case of fire, it protects the building from smoke and toxicity. I brought these examples because depending on sometimes there's lack of information about what is a vapor, what is a breather, when use one, when use the other one. For instance, when we compare, for instance, in the facade details, if we have a temperature outside of 40 degrees with 60% humidity, and inside 22 degrees with 40% humidity, we should block the vapor from the outside. So if we are using a breather membrane, we are using the wrong product. The right product for instance, Middle East markets, is to use a vapor control layer. We should block the moisture to come from the outside to the inside. So saving lives through application of non-compostable membrane. So if we have the knowledge of the market, if we have the knowledge in terms what are the needs of the customer, if we understand the needs in terms of fire, and if we have the right partnerships with the industry, with the different agents in the market, then we can add value. Then we can bring something that in our scope can help to save lives. And this work that we've been doing for the last years, we proud ourselves of this, because in our details, in our particular products, we can say that we are helping to save lives. And this is something that we proud very much ourselves. I'm very happy also to bring, and this is a very new thing that we launched, that is a worldwide unique product. So in the facade, we know the challenge of interfaces, and we know the challenge in terms of having a product that is fire rated at the same time is flexible. So we worked all these years to be able to develop the last piece of the puzzle. So we have the breather, we have the vapor, and now we have all the interfaces that are fire rated. We have a Proflex membrane that allow the movement. So this was something that was lacking in the market, worldwide market. I'm not exaggerating, it's a worldwide new product that is fire and at the same time is stretchable. So we completely the family of fire-rated solutions. And this is completely unique. This was launched last week in London. So it's a very unique thing, and I'm proud to bring this here today. So we, together with our partners, we can deliver a solution to the market, to a project that is one completely system with one only warranty, that is water, vapor, and fire resistance. As I mentioned, I brought some more case studies because having only the certifications or only the products, it's important, but more important than this is to have actually the products, the solutions applied in the market. So I brought from some, for instance, this is Dubai Eye, where we apply a vapor control layer, protecting the insulation, and we connect with our different accessories. Icon City, so all the interfaces we sealed with fire-rated solutions, that is a vapor control layer and fire rate at the same time. Another detailing in a Dubai Creek Harbor. This project, I think all of us know, so they are doing the recladding, and in this recladding we are using a vapor control system, and we are warranting the waterproofing of each penetration. We use this also in UAE Pavilion, X2020, we use the same solution. We brought some projects from Europe, from UK, for instance, where this was very demanding project because we needed to have the different systems combined. The vapor system with the breather system and with all connections in the perimeters. So this is something that I mentioned we can completely customize according with each product, according with each region, according with each detail. So this is a bespoke solution. As we can see, you can completely develop solutions that are bespoke. Another example in Madrid. Another example in Paris. So just as a resume, we have completely integrated systems that are test and approved, that are technical superior. We have different kinds of certifications according with each market. Another thing that is very important is sustainability. People speak a lot of sustainability. There was like a myth that, okay, something that is fire rated is not sustainable. No, we don't use any kind of raw materials that warm of the environmental. So it's VOC-free materials. We can completely customize, and for us, it's very, very important to be very close of each agent, facade agent, to understand their needs and to customize and develop solutions. It's a continuous work of develop and customizing solutions according with each need on each project. So thank you very much. Thank you for your time. It was a pleasure to be here. Thank you very much. Bye.
Thank you. Good morning, everyone. My name is Osama Radwan. I'm a chief architect and designer in Umrani and Associate here in Riyadh. When Zak approached me to give a presentation today, we discussed internally on how we should deliver a kind of a very useful and practical information about design and practicality and appearance of the facade design in Saudi Arabia. I would like to give a kind of a brief explanation on what we are doing in Umraniya. Umraniya is a multidiscipline office started in 1973, so it's almost like 50 years in the market, doing architectural, interior design, urban design, landscape, structure, MAP, civil, infrastructure, and value engineering, beside of the contract administration, which is the site supervision. As I mentioned right now, we started in 1973, very small office in Riyadh, starting doing design of kind of a small scale projects. Going through those years, we designed a lot of buildings, varieties of categories, hospitalities, office building, residential, industrial, and now here we designed one of the biggest park in the world, which is the King Salman Park, one of the tallest building in Riyadh, the PIF Tower. To start the presentation, I would like to open a statement very important, which is a facade shouldn't just dictate how the building looks, but how it works, especially in a harsh climate like Saudi Arabia in general. In Umraniya, our work is actually dictated by what we could shape by 4 P's, which is the performance and price, prefabrication, and post-occupancy. To deliver the message of how sustainability and practicality of designing facade could be achieved during a design process, we choose 5 case studies. The PIF Tower, which has been designed in 2009. Hilton Hotel, a well-known hotel in eastern of Ring Road of Riyadh. Radisson SAS Hotel in Diplomatic Quarter. Metro Station on the western area of Riyadh. And Saudi Electrical Company, which just 2 years ago has been started to operate. As I mentioned just right now, it's easy to remember those 4 P's all through the presentations because we will always refer to those 4 P's in every single case study. First case study, which is the PIF Tower. Highest tower in Riyadh, 385 meters, 182,000 square meter of gross floor area. Expected to be completed next year, 2023. The client, PIF Tower, will take over the project very soon. It's 80-story height building, and as we said, it's the tallest building in Riyadh. The design of the tower is a prismatic geometry and inspired by the rose crystal found in a wadi of Saudi Arabia. It's always cracked after the water dried from the rain. It's 2 buildings. Everybody is appreciating the tower itself, but actually there is a small building next to that. We call it the podium, which we're going to explain right now. Also the design of the envelope of the small building as well. Optimized for thermal control, natural daylight, energy performance, and view. Designing the envelope of such a building is not an easy task, because you have to consider, beside the appearance and the aesthetic aspect, the practicality and the sustainability of the design. So we started the design of this envelope by establishing how many layers we need to design as a building envelope. And in this tower, we have 3 separate layers of the building envelope. The first layer, as you could see, is the glass fence, which has an aesthetic and function. The aesthetic is to give the faceted appearance to the tower, which the designer wanted to have. The functionality of it is actually, it's a shading device for the glass, for the facade itself. The second layer of the building envelope is the shading devices, which is the catwalk, a perforated catwalk, and a metal shading device, horizontal shading device, to cast shadows on the glass itself. The third layer of the envelope, which is the low E triple glazing system, very unique to find in the region, contains of 3 layers of glass with 2 air gaps. As we mentioned, that we have the tower and the podium. To get into detail, the glass fin is actually away from the facade by 80 centimeters to create a space for the building maintenance, the people who want to clean the glass and replacing the glass panels. All right. The podium. The podium has been designed as one volume. Again, we have 3 layers of envelope, starting with a steel structure. We call it a digrade. Then we have the glazing, which is kind of wrapping up the steel digrade from outside. Then we have the shroud, which is the perforated metal panels covering the glass from the outside. As we just mentioned right now, this is the shroud. Then we have a space of a kind of catwalk to clean and maintain the glass, and the glass itself, and the inner layer, which is the steel digrade. We used a kind of a unique glass type on the roof of the podium. We call it the nano gel or aerogel. This technology is being created in Canada from a company called Epcot, which is a kind of injecting the layer of the glass with a material called the white gel. 95% of this material is silica, so it's almost like a sand. Insulation of this glass is about 95%, allowing the light, as you could see from the right up photo, allowing the light to penetrate, but doesn't allow the heat to go through. To give the ambience which the designer looking for in the podium, which having like a kind of a glass box. We have also an energy cost saving, the format of the photovoltaic system on the roof, securing about 1% of the total energy of the building. When you talk about 1% of this size of the building, it's a lot. Also located on the roof and the intermediate services floors, building maintenance, BMU system, that works with the external catwalk to provide access for cleaning and maintenance. Let me just give a kind of a brief explanation on how the BMU works together in integration way with the building envelope. The BMU itself, it will go through this crack, which is the glass, we call it the pleat, as a taxi. So the maintenance staff using the building maintenance unit, descending from the roof and stopping on every floor, allowing those staff, the cleaning staff, to go on the catwalk and coming back to the BMU itself, the cradle. In each level, the water and the power already provided. So they don't have to bring any hose, they don't have to bring any water bucket or anything. Everything is already secured in every floor, in this area and that area. This is a kind of a detailed plan on how the BMU working, 1, 2, 3, through the pleat, the crack. Second case study, which I would like to shed light on, is the Hilton Hotel on the Eastern Ring Road. There are 2 buildings. One is the hotel, 20-story height, and the other one is the residential building, the residential apartment, which is 6-story height. The design, the original design of the project, we started with a challenge. The land itself, it has a different level, and the client wanted 2 buildings to be built or to be designed on this land. So we decided to have 2 separate buildings, going with the different, we explored different concepts, straight, angled, and Y-shape. Finally, we choose the Y-shape, double-loaded corridor in every arm to actually maximize the views from all the sides. We have 3 levels of podium. This is the final shape of the project. The size of the stone we used, it's an artificial stone. With size of the stone itself is 1.5 meter to 75 centimeter. The joint on the stone itself actually aligning with the glass to give the horizontal appearance of the tower. We also designing the glass itself in a very special way. It's always slanted or recessed toward inside to give a kind of privacy for the rooms of the hotel. We have 3 recessed a kind of pockets in the facade and the elevation itself, so the people from inside could recognize in which level they are. And these 3 pockets actually alternately switched from this side to the other side. This is the residential building. You could see the main lobby and how by creating double volume, the facade itself casting some natural light in it. The third case study is the metro station. Metro station of Riyadh, when we started the design, we got inspired by the sand dunes around Riyadh desert. And to achieve that, the curvature of each buildings, we used a kind of a precast GRC panels with steel structure. It's still under construction. That side, this side is still under construction. There's a gap in between, and those 3 curvatured or parabolic shape still under design right now. When we talk about how practicality and sustainability actually dictate sometimes the designer to achieve the optimal goal, in this particular project, we faced a challenge on how to achieve the curvature using rectangular stone. Through the design process, we use a very complicated software to give us each panel, the size of each panel. Then we realized during the design process that rectangular block doesn't work. We changed the size and the shape of the block to be a trapezoidal. We used a 4-dimensional program with a joint of 2 to 5 millimeter. All right, in this section, you could see the outer skin of the station made out of stone, but actually there's another layer, inner layer, which is the main roof from inside. It's a steel structure with the waterproofing, thermal insulation, everything actually inside the inner envelope. The outer skin stands on the inner roof by steel pedestal with an open joint. So the stone on the outer skin of the envelope is allowing the water, dust getting inside, protected by the inner roof. This is the interior of the main arrival and departure terminal. Okay. I think we are done with this metro station. Now, the fourth case study we choose this morning is Radisson Hotel Blue, or Radisson Blue Hotel in Diplomatic Quarter. It's located in the heart of the Diplomatic Quarter, 110 rooms. The client wanted us to accommodate 110 rooms in only 4 floors. When we went back to RCRC, which is the Royal Commissioning of Riyadh, they said you cannot, as a building regulation, you cannot exceed those 4 floors. When we calculated the gross floor area versus the available area limited by the authority, we realized that we need a complete floor, additional floor to add. So what we did, we sunk 1 floor totally to create an English court with a lush landscape. And surprisingly, those rooms, before we explored this option, we were really a little bit reluctant to sunk 1 floor. But eventually, when we started to design them and surround them with landscape, trees, the hotel now started to be operated 2 years ago. And the most expensive rooms into the hotel are those rooms because they have their own private terrace. When we started to think about the building envelope of the hotel, we explored the option of having, again, a separate layer of an envelope, either recessing to create a terraces, either inward or backward. We used a terracotta material in 3 different configurations. Either an opaque, solid terracotta material, or kind of a louvers, and we call this a baguette, 4 centimeter by 4 centimeter, in different density. Though the material itself is lab tested and actually created a kind of an insulation and a barrier between the outside and inside. As you could see, we created a kind of called rain screen cladding, detail number 1, 2, 3, and 4. You could see easily the sunken floor and the activity there. Also, the designer created kind of screen on top of the double volume to mitigate entering the sun directly to the lobby. Last case study, which is Saudi Electrical Company, SEC. The main concept here actually to create the biggest volume of floor space versus the usable space, and at the same time it was a challenge because how we are allowing natural daylight getting into those buildings. The designer, we used kind of horizontal shading device. Again, the same concept, creating a catwalk in each single level, and the third building envelope, which is the low E glazing system. The shading device, the horizontal shading device, has tilted in a different way in each direction. So sometimes in the south, we tilted more horizontal because of the sun. On the east and west is more vertical because, again, of the sun angle. And those perforated aluminum panels would cast shadow on the glass. And surprisingly, the cooling load has been saved by about 30 to 35% in the building. This is from inside. See how this is a real photo, an actual photo. The offices, all the offices from three directions, looking toward the main lobby. See how you appreciate how the natural light getting into the office building. It's one of the best office floor designed right now during night. Okay, finally, designing an integrated and envelope system that consider performance, price, fabrication, and post-occupancy is not an easy task, as everybody knows. But we believe it is necessary to promote sustainability and practicality in our design process. And when it's done well, believe me, it will be an efficient envelope, beautiful, can be beautiful as an ornament. Thank you very much.
Hi, Brent. Hi, thank you. Thank you. Assalamu alaikum. Good morning, ladies and gentlemen, and welcome to Serge Ferrari Group. My name is Mohammed Bahsh. I'm the Senior Manager in Tensile Architecture for Serge Ferrari Group in Asia Pacific, Middle East, and Africa. I'm very happy actually to wrap up our participations in Zak this year in a lovely city of Riyadh. Today we're going to take you actually into the group, which is two companies, Serge Ferrari and Verzadek, very active in 4 key markets, which basically starting with the tensile architecture. And that's, we're covering all the tensile roof, facade, shading elements, but also acoustic. The second important segment for us is the modular structures, where anything in temporary solutions comes in fabric. Third pillar for us is the solar protections. That's for indoor or outdoor blinds and roller curtains. The fourth important key segment for us actually is in the furniture and yachting. Anything related to the outdoor furniture or the furniture that requires a maximum resistance to the UV. We are also active in specialty markets such as military, such as automobile, and etc. For today's presentation, actually, we're going to take you into our solutions in facade industry. Basically, if we look at the fabric in facade, we take it from the French meanings, which literally means the face. In architecture, actually, this is very important. The facade is the most important from the design standpoint, as it sets the tone of the complete building. Most important part when you are assessing fabrics in facade industry, you look at the fashion, how you can create the identity, how you can set the sort of exclusivities or the landmark images. It's not only just the pretty faces, but also it has to function, it has to perform. And the most important part here, actually, when we talk about facade and fabric, we're looking at the maximum durabilities in such a harsh environment as in Saudi Arabia to resist the UV, but also other things such as fire behaviors. The most important part for us here is how we can maximize the natural light, because people perform much better in the daylight environment, but surprisingly, almost 90% of our time is spent indoor. Of course, day lighting is associated to increase the morale, to help motivate productivities, and it has less stress. And that's actually basically we have the four pillar of textile facade benefits. We have how we can maximize the natural light in by providing a maximum translucency, yet control the glare and control the thermal comfort, but also to provide the maximum privacy. And that's basically is the most important things. So if we look at typically what the high performance textile facade, we have to improve the indoor environment. We also by enhancing the sun protections and the comfort, the thermal comfort, and accordingly, we expect to reduce the energy consumptions, but also to increase the value of your buildings. We have two constructions way actually to take in consideration when you are assessing the tensile fabrics. We have the modular membrane facade. This is a straight modular structures, or you can create the 3D images into this. But also we have the tensioned membrane structure, which can be a primary structure into your building using a cable structures as what we have in Burj Al Arab. So basically today we're gonna, with the 10 minutes left in today's presentations, we're going to cover quickly the key benefits of assessing the tensile facade. First is boosting the design identity for your projects. And here we have three most important benefits. Basically, the first one is the modular and 3D dimensional structures. If we take this Airbus headquarter project as a good example, you see you can create as a second skin facade structures into your building. By providing a maximum daylight privacy, but also thanks for the micro perforated mesh, you can boost and increase the visibilities from inside to outside of your building. The membrane is very lightweight structure, but it has an excellent high mechanical properties that can allow you also to go high in buildings. This is one good example in Germany with just under 250 meter height. As we are in Saudi here, we can touch base some nice projects in Saudi. This is Tajreed Center in Riyadh, where also the client wants to add some kind of identity into the building by providing a 3D second skin facade structures. Lighting and projection, and this is one of the unique part of tensile architecture, which you can completely transform the performance between daylight and nighttime. And that's what you can see here actually in how you can play and how can LED projections can play a significant role in boosting the identity of your project. This is just most recently from Qatar. This is Lusail Plaza in Doha. And you can see actually how membrane can provide an excellent screening for projections and so on. Yet, do you need to customize? Yes, you can do printing. okay? And the printing also can last. The second one is the visual comfort and glare control. A good example here, this is a Fritz Institute in Germany, where a second skin has been introduced to the building. And that's what you see, the day, night, and nighttime, what you just mentioned. But also the most important things by providing an external shading system is by protecting from the diesel, and while conceiving an excellent natural light into the building, and of course improving the lighting quality and the visual comfort of what we expect, and that is the most important part here, is the thermal comfort and energy saving. This is one of the unique part here when you are introducing the fabric as a second skin into your building. By improving the quality and reducing the energy load by using a natural ventilation scheme, employing the facade as a second skin to be as an active air control elements. The airflow which goes between the primary skin and the secondary skin will help actually to reduce the final temperature touching or entering into the building. A good example of this, I can bring this as a good example. This is the Silver Spar office building in Los Angeles. Basically, this could be perhaps the most amazing example of the system value. This is the 15 years case study in Los Angeles. Prior to the 2005, the client has extremely suffered from the high energy bill, the high energy expenses. By investing only in $200,000, okay, the client managed to save a $60,000 per year, okay, creating a total of $700,000 from the initial investments of $200,000. So this is a very good trade in business actually to create a significant saving into your buildings. Most important part, and we know of course this has become a very important into the construction norms, is how this material behave under fire. In Serge Ferrari Group, actually, we lead two leading technologies. We have the PVC material, but also we have the PTFE material, and each one has a different performance under fire. The PVC usually is a fire retardant, while the front runner of the industry here is the PTFE fabric, which is a non-combustible Class A material. And as a result of this, there is a growing business for architects actually selecting the PTFE material to choose for as a single skin multi-car park facade. A good example here, this is Berlin Stadium where it's used. There are a different kind of mesh. We have one exceeding 50% opening, which meet also some countries' regulations in this part. But also the most important part here, this is how this material behaves superiorly under fire. Riyadh, you have so many old buildings here. And there is the need of renovation, how you can bump a new life into your building. And this has always been the questions how we can do that. Fabric is a very lightweight fabric, it's a lightweight concept which you can insert into the renovation business. We can take a good example of this, but also it can be into an iconic large projects where you can bump a new life. But it's not necessarily only for the fashion, but it can help significantly to answer the thermal concerns and thermal or energy saving, creating an energy saving into your building. This is a good examples here, some projects here and there in Riyadh, since we are here, is to bring some case studies actually into how an old building can be transformed and bumping a new life into it. Just to touch base quickly, the type of perforations and the difference between the fabric, the textile, and also the macro perforated metal mesh is mainly the visibility. And the visibility is the most important part here. What you see here on the left side is from inside outside through fabric, but here in the metal mesh, and you can see the visibility is very much interrupted actually using the large macro opening in the metal, while in the left side you can see the clear through the textile. also in the group, we have a tremendous solutions that covers both two leading technologies in the PVC and PTFE from both Serge Ferrari and Verzadek. And there are, of course, different colors to discuss outside. In the PTFE, of course, we have the large opening and also the small opening, which these materials are unique in terms of cleanabilities, but also in terms of fire behaviors. PTFE, since we are in Saudi Arabia, and there are a long track histories of using PTFE into projects, such as in Jeddah, Hajj Terminal in Jeddah, or Mina Tent, and, or King Fahd Stadium in the 80s. The fabric, is considered to be the front runner of the industry. It has an excellent durability, it has low ratio of maintenance, and it has an excellent long-term dimensional stability, but also an excellent resistance to different kinds of chemicals. Touch base, a quick case study here. We talk about Burj Al Arab. Burj Al Arab, I always bring this as a good case study because it's a vertical structures. And you know, with a vertical, you have a direct contact of sand. And this will have usually an abrasion kind of forces. The project is still standing in good shape since the 90s. And it's because of the nature of the material technology itself. It's still even used, the surface of this structures is used usually for celebrations, projections, and still providing an excellent touch base. Quickly, I'm looking at the time actually, just touch base here, landmark projects in PTFE and our contribution into this industry. You will see there are so many projects in the historical project in the two holy cities of Mecca and Medina, Medina Airport, Hajj, the Jamarat Bridge, but also the Haramain railway station, which connecting the two holy cities. A fabric, which also please come and check outside. This is a new technology by Serge Ferrari, where we are providing a maximum light translucency and combining the indoor protections with an outdoor feeling. Okay, it has more than 50% transparent value, and that's what you can see, which you can still combine with the other material. Touch base. Since here also, hopefully that we can see one day Saudi hosting the World Cup in the next 10 years. Fabric and in the stadiums, yeah? Just to touch base actually how material can transform and boost the atmosphere of such an event. Just here we will touch base our contributions. We had a very successful participations this year in Qatar with being heavily involved in supplying fabric for 5 stadiums. Al Bayt Stadium, this is a unique colored PTFE fabric in beige and in a Bedouin shade structures. Also we have a Jagguard technology for the inner membrane for the acoustic performance. A Thumama Stadium for the facade and for the roof with such a low G value also required there. Education City, it's a unique facade mesh membrane structures. Lusail Stadium, also a unique roof supplied from Serge Ferrari Group. And the Rayyan, last but not least, the Rayyan. Touch base also here for other structures in the expo. We had a very good participations. So basically, that's what you see here. This is a project here also in Riyadh where you can still combine the steel and fabric. And you can create, this is a Mercedes, by the way, Mercedes headquarters. So you can create you can form the shape you want basically. And it can help you. It's a very flexible material where it can help you actually to push the imagination and bring values to your project. Basically, so it's not just a pretty face, it's a face that is functioned. It can add value to your structures, but also it can last. I mean, the projects we have in the Middle East here, particularly in Saudi, for some technologies such as in the PTFE, it's now exceeding the design life of 30 years, and I think it can still run and perform for the next 10 years comfortably. That's it for today, just running on time. You know, I could take longer time, but if you have any questions, please, we are outside. Serge Ferrari Group, you come, we can show you, touch and feel the material, and we're here for your support. Thank you. Try to be quick. You're welcome. Cheers.
Thanks. So, a warm welcome here from the stage at Zak World of Façades. I'm very happy the previous presentation already has been showing two of our Vinay Sharma projects. Also, one of the previous presentations were talking about 3D modeling, about BIM, about Revit and Grasshopper. This is one of our projects. We designed this project around like 12 years ago, fully in 3D with Grasshopper, Revit, and this is how it looks like being built. Now, who we are, my name is Mr. Benjamin Beer. I'm working for Vinay Sharma. We are a Germany headquartered engineering consultancy. We have about 350 people worldwide. We have offices from New York to Moscow, Istanbul, Germany, and Dubai. We have projects all over the world. And what we do is we do structural engineering, facade engineering, sustainability consultancy, and also MEP engineering as a rough kind of overview. Now, talking about green building design and talking about sustainability, this building over here is so green, it disappears within the green landscape. So this is green building design. Now, is our generation, have we invented green building design? Or can we learn from the past? Now look at this, maybe we need to look backwards. Now this building is about 400 years old, and it shows a nice example of a green building design being 400 years ago, and the building is still there. Now looking at the specification of this facade system built 400 years ago, it's a double skin window facade system. It has operable natural ventilation. It has operable external shading by the green flaps. It has operable internal shading by the blinds. It has adjustable U value by opening the outer or the inner windows. It has a low maintenance. It is environmentally responsive. It is fully recyclability, all the metal parts. And it's fully biodegradable for the wood and timber if it's not painted with some chemicals, what we did only over the last 50 years. Now, are we guys, nowadays, are we smart? Or have these guys been smart 400 years ago? Now, this facade specification, if we put it as a facade consultant into our nowadays projects, I think a lot of facade contractors would fail. Now, let's go on. This building, also the CO2 emissions, the barn with the animals were usually in the basement, so the warm air goes up through the open floor and goes up to the lower floor, up to the floors. There was one stove within the whole building, so the CO2 emissions of this building is almost CO2 neutral, yeah? So learning from the past. Also looking into hot climates, what happened here in the past is that people built wind towers. There was no air conditioning. The wind towers were collecting the air and funneling the air down into open courtyards. A lot of projects have been built. This is how people survived in the past. Also, the whole idea of this mashrabia, which is a window of facade which is open, so it provides shading. Nevertheless, it lets the air to penetrate through this mashrabia open screen, so get a natural airflow. So also about shading, so relatively narrow streets, narrow pathways, people walk in the shade. Now the question is, can we transform these technologies from the past into the present? To a certain extent, yes, we can. I think one of the key issues that we need to understand is about thermal comfort. It's about we building buildings for us as a human being. This is the intention, this should be. Now, we as a human being, can we go back to the construction methodologies that we had in the past? And not really, because it is about thermal comfort. And there have been studies in the past where the US Army exposed people to high temperatures. And of course, people felt unwell, so the thermal comfort wasn't there. But after around 3 to 4 days, you can see how this curve goes down. So then people acclimatize to high temperatures. Yeah. So in principle, we as human beings, we can go back to the old design, but it wouldn't feel comfortable, especially for the first 4 to 5 days. Yeah. Now, can we transform these old methodologies to modern times? This is one of our projects here in Riyadh, which is the Al-Mishraq canopy. Now, we want to create a more comfortable outdoor space. Yeah, so people want to walk outside. So it's about shading, it's about natural airflow. Combining these two things in a kind of big scale of a city. Yeah, what can we do? So this is a project we're currently working on with CRTKL. It's about a large shading structure connecting almost a half of a city, kind of big, yeah, kind of development. Now, the idea is that these wind towers, you can see over there, they collect the airflow and funnel the airflow down into street level. When there's no natural airflow, we're going to have fans and put mechanical ventilation to get the air going down. At the same time, we're using so-called, actually evaporative cooling. So we're using moisture that we spray into the wind towers to cool the air down. Now this kind of thing, it shows a bit of a scale. We have up to 80-meter clear span, a free-form grid shell structure completely designed in 3D based on structural optimization. I'll go through this twice quickly. A fully 3D grasshopper design. You can see the red lines were the original architectural design intent. Then the blue lines are the structurally optimized perfect curvatures of grid shells, so structurally optimized. So we remodel shapes to make them structurally more efficient, take the steel tonnage down. At the same time, there have been CFD studies done by RWDI. So with the orientation that we have two openings in the wind towers at the top, so we know the two main wind directions, and we have open flaps that open and close depending on the wind direction to get the air down. And this shows on the bottom, so on the top left side, how the thermal comfort of the people on the pedestrian level is actually enhancing. Yeah, so we can create a kind of comfortable outdoor climate for about 3 to 4 more months. Yeah, that people still feel comfortable. The wind towers itself, it's a combination of us doing structural engineering, facade engineering, and the full MEP design. So it shows a bit of the complexity of these wind towers. We have the opening at the top, the funding they are down. We have to have full maintenance access to the inside for all of the mechanical parts. The good shell connects on the top left side. You can see over here the maintenance. So we are doing this modeling fully in 3D, including the MEP equipment. In case there's no natural airflow, there's no wind, we have to mechanically push the air. You can see this is a kind of rotating drum that can direct the air from the two main wind direction. We can see also the kind of misting system, which is spraying kind of water mist to cool the air down that flows through the wind tunnel. We see the diffusers, the mechanical part on the left and right hand side. We see all of the membrane structures. It's a large grid shell shading structure with the membranes as a shading device. We see here all of the nodal points. So this is fully engineered by Vinay Sharma and now going out for tender. Some more images showing the mechanical equipment. We have about 2 sides. We suck in the air, we blow the air down. We have silencers so that the noise level are still within reasonable limits. All of this has to be designed and designed fully in 3D. Talking about exterior shading, the Expo 2020 in Dubai, Vinay Sharma, we've been the designer, the lead consultant, the architect, structural engineer, facade engineer for these big shading structures that open and close. A very successful project for the Expo. It shows a bit creating more comfortable outdoor thermal environments, especially in the Middle East, where shading is key. In the Middle East, if we don't have shading, people don't feel comfortable. This kind of aerial view shows a bit of the scale of the shading elements, and I think most of you have been to the Expo. It looks amazing, both during the day and during the night. Now, I hope this video works.
That we have to reduce dramatically the emissions. The announcement is to reduce CO2, greenhouse gas emissions, within 10 years by 55%, which is something different to save 55% of energy consumption. This is even more difficult to be achieved. Everyone underwrites that, but nobody really makes clear to himself what that means, because if we are not capable to change the technologies we use to produce the materials, to build the buildings, to run the buildings, and to demolish them, if we are not, then in 10 years we are allowed to build only 45% of the amount we are actually building. Means half of us is becoming unemployed. Standing in front of a problem which says, okay, either you change everything or you cannot build in the way you build nowadays, will urge this interdisciplinary process that people start talking to each other and say, either we invent something or we are lost.
So this was Professor Vinay Sharma, the founder of our company. I will go through this relatively quickly. The Expo, again, creating a comfortable outdoor environment, using new technologies, operable and closing these shades. What's nice about these shades, we can see the direction of the stresses. Yeah, so the membrane are woven in a way. This is a bit of similar to human bone. Our bones of a human being, they're direct material in the direction of the main stresses. And a similar thing was done for these membranes. So you can see the membranes have certain fixing points, and in the direction of the main tensor stresses, the strands are orientated. So it's about energy saving, it's about CO2 kind of reduction of emissions and creating more structurally efficient systems. Now, This video shows how they open and close. I will go through this relatively quickly. Now, this project was shown before. It's about what is the next step. So what is the future of facade engineering will bring us? So far, we did a lot of projects with aluminum glass. What about membranes? And we see more and more projects coming in with membranes. We're talking about translucent materials, not transparent, not opaque, something in between. These membranes can be open, they can be permeable. They provide shading, but at the same time could to a certain extent let natural airflow pass through the membrane. This is ThyssenKrupp Test Tower, a very tall building, I think the biggest membrane facade in terms of height that was built worldwide. With Murphy, you can see beautiful design. You can create kind of seamless cladding of buildings, yeah? Being translucent, providing shading, providing partial view and partial airflow through the material itself. This is a Winterford photo. Now, some of the research projects that we're currently using, we are currently looking into evaporative cooling. And evaporative cooling meaning as a facade system, as a permeable, translucent, not closed, not open facade system. Now, this is a water drop hitting a surface. Now, on this side of you can see a water drop hitting a hard surface, like a glass surface. On the other side, a water drop hitting a micro-textile surface. And the water drop then dissolves into kind of water spray, yeah? So we have started creating with the University of Stuttgart kind of a microfiber system where the water drops can be collected and then can be evaporated into the air, yeah? So there's been a test tower currently built and a facade system being built with several layers. The idea is the following: we spray water from the top and we use this facade system, this permeable, open, translucent facade system as a cooling device, yeah? Especially for hot climates. So the top left corner shows a bit of testing that's currently ongoing. You can see the system itself just by water running onto the system at the top using these microfibers. To get this evaporative cooling, we can drop the temperatures up to 10 degrees, yeah? So it's about a new technology, a new design. So what are the next steps? And I think the kind of future will be this kind of either textile, membrane, semi-permeable, microfiber facade systems for several reasons. Now, this kind of system also brings me to the next topics about light. I want to talk about light and about human-centric design. This is how a lot of offices looked like in the past. Now, we need to understand how light affects us as a human being, especially for the facade engineering. Now, this map shows the overlay of depression and anxiety in the United States on this side. And the other side, on the right-hand side, the average daylight intensity in the United States. So you can see that California and Texas, the states with a high amount of natural daylight, have the lowest amount of depression and anxiety. So we as a human being, we depend on light. And there's been new studies out in the United States that about 87% of our time as a human being we're spending indoor. We're spending this time inside buildings. So our facade system becomes extremely important in terms of what kind of light quality are we as a human being getting through our glass panels, yeah? And this is also some research study where we're currently looking into, so what kind of glass do we need? So these kind of graphs show the spectral emittance, for example, and the transmittance of different pieces of glass. So what kind of solar spectrum is coming through the glass, yeah? And what do we need as a human being? And the evolvement of the solar control coatings that we especially have here in the Middle East shows that our glass is more and more getting solar selective, meaning we are filtering out certain wavelengths to reduce the energy consumption of our buildings, yeah? And this, you can see at the bottom over here, this is so-called triple silver low E solar control coatings. So what's coming through our modern glass, it's only the visible spectrum that our human eye can see, which is roughly between like 380 nanometer and 780 nanometer wavelength. All of the long wave infrared radiation is reflected back out by the solar control coating. And this is the thing we're researching into. And the same happens with the artificial light. Going from traditional light bulbs to LED lights, the same happens, yeah? So we're currently looking into this whole thing about what do we as a human being need, yeah? What kind of light do we need? For example, people are taking sun bath, and they're sunbathing because of the long wave infrared heat. They wouldn't take a sun bath under LED lights, they wouldn't. And they also would not do a sun bath under our modern solar control coated glass, yeah? Vitamin D production, we as human beings, we get light onto our skin and we produce vitamin D by the light, but what wavelengths of light, yeah? There's been research about cancer. There's now cancer treatment by long wave infrared radiation on the skin. Newborn babies, they get jaundice. So which means that the lever is not working well, and they're using certain wavelengths of the blue light spectrum so that the blood is getting cleaned by this thing that comes through the skin. So this is about this is about 460 nanometer wavelengths. So we depend on light. There's been a Nobel Prize on certain things. So this is so-called circadian rhythm. So we as a human being, we need the blue light spectrum to keep awake. That's why all of your mobile phones, all your Samsung, iPhones, whatever, they have a night mode where the blue light is taken out. So it's getting more yellowish. And this is for us important, so we fall asleep. Yeah. Now all of these kind of things, we know the light transmittance of glass is a figure, but we now have the so-called melanopic light transmittance of glass, which means we started looking into glass in a different way. We started looking into glass with a transmittance that's important for the human being, not only for the energy consumption of the buildings. Yeah, so it is a whole new thing, and we call it not the VLT, the visible light transmittance, we call it the melanopic light transmittance, which is focused on the blue light spectrum that's important for the human being. So this is how we nowadays evaluate glass. Yeah, looking about this melanopic thing and about 400 nanometer wavelength that we usually like, that we need as a human being. What's this kind of color range? It goes from the bright blue to the bright green. Yeah. And what are the two colors? If you wake up in the morning, you look out of the window, what you want to see? A clear blue sky and green. And this is the two colors. Yeah? This also brings us to the construction, back to the construction. This is New York. All of the apartments with park view, you can increase your rent, you get higher income with park view. People want to look into the green, because these are two colors, so green and the light blue. Now, what if we now take the park and get our building being the park? This is one of our projects in Düsseldorf in Germany, one of the biggest green buildings built so far. So we took the park and put the park into the building, or the building became a park. It's not only that the building itself is very green, it's also all of the adjacent buildings. The rental income of these units, they go up because people look into a park, but they're looking at the building. Now, just quickly going into this green facades, we have the plants, of course. We grow the plants. It's usually prefabricated. We have all of these trenches with the kind of planter boxes. We have an irrigation system for the water. We can then select plants which are green all of the time, which are less green. This is how these things are getting stored, all these planter boxes. Then they come into crane, they're usually pre-craned, come into the position, and actually getting stored. Now, this kind of green building design, it's a thing how we can resolve several issues. We have the heating up of our cities, so of a kind of a microclimate enhancement, because we're cooling down our cities naturally. We filter the air. We increase the value of the properties. Yeah, and this is how it's built. Now, also want to go on a bit of more research that we're currently doing with the Fraunhofer Institute in Germany, with the University of Stuttgart. We call it digital twin. So our real buildings have a digital twin, yeah, and 3D twin. This shows a bit what we're currently trying to research. We are looking into double skin facade systems. We're looking into active facade systems. We're also looking into so-called decentralized facade systems, meaning that our MEP equipment is not in one floor of a building. We're using MEP equipment which is decentralized as part of the facade system. The whole thing is then controlled via 3D virtual reality glasses. So you walk along, and I hope this video not going to show the whole thing. So take on your VR glasses, or virtual reality glasses, and the facility management can then walk through the building, and each unitized facade element is active. Yeah, and you look at your unitized facade panel in a 3D virtual space. You can select certain data, and then you can look how this unit currently performs in terms of shading performance, is light, and then you can go through it. In a 3D environment space, you kind of overlay the real view of the facade unit with a 3D screen, and you can see certain data. You can flip with your fingers and go into each unit with the data that each unit has. Yeah, so we call it a kind of digital twin. So you walk through the real world, have a VR glasses, and your digital twin is then projected into your VR glasses, looking at each unit and selecting certain data. For example, put the blinds up, put the blinds down, open natural ventilation, get more air in and out, and so on and so on. So this is currently a research project we have with Sealy and with Zeiss. I will go on. What's the future? What is the future of facade engineering? Where do we want to be? Did we learn from the past? What's the future? Now, we're always doing some research projects. So we're looking, where can we be in a couple of years? So R129 is one of these jobs. We're thinking about a kind of monospace, a glass shell. Just a glass shell that is actively reacting to the environment. Now, this glass shell looks very futuristic, but we're taking some goals as a technical research project. So with this kind of glass shell, we're looking into several things. We're looking into switchable glass, into vacuum glazing, into chemically strengthened double curved glass. So we want to create just a hull, kind of shell, a complete glass shell that is capable of taking all of the thermal and requirements. Now, this looks very futuristic, and the next photo shows we have a mock-up. Yeah? So this is a glass shell, just glass, no steel, no aluminum, nothing at all, just double curved, chemically strengthened glass, two-way curved, with about, I think, 12-meter clear span, with a titanium ring around for the different thermal expansion. So talking about the future, I started my presentation with looking to the past, and even the people in the past have been smart. Now, are we as smart as the people in the past? I really hope so. Thank you, everybody.
Thank you, Bart. Yes, good morning. We're just jumping in. Time has started, so I don't want to get the bell, so I just keep on moving. Yeah, I'm from Schüco. Just a little teaser what we are going to hear about today. It's about our pre-construction services that we offer to clients, architects, and specifiers. The products, very brief, because Schüco probably is known, but not so much all the offerings that we have in terms of products. Then I'm going to talk about how we apply our pre-construction services on a specific product, which is our grid-to-shell product. And by that, I'm going to introduce you to that grid-to-shell product. At the end, you will see a lot of pictures, because pictures are saying more than 1,000 words, and how that product was applied, and how our services were applied. Now, Schüco, as a company, we are more than 70 years old. Our founder, Mr. Schürmann, is the name giver of the company, Schüco, Schürmann and Company. The offerings that we make in terms of product range, we are working on the building skin. Now, if you talk building skin, we're talking about the vertical parts of the building, which is the doors, the windows, the facades, which is can be stick or unitized modular building. We have heard about previously from Omrania, the colleague, he said, the 3 Ps, and one of them was modulation, prefabrication. It's a big topic. The materials that we work in the skin, the building skin, is aluminum steel fabric. Serge Ferrari was here. You're going to see one of the applications within our system. And UPVC, that is probably not so much known, but we do have also UPVC. If we talk about building envelope, then we are talking about the roofs as well. And in the roof application skylights, we do work with aluminum and steel. Now, the products that we have range also into safety and security. Safety, we do the traditional smoke, fire rated from 30 minutes to 120 minutes. We do have glass balustrades preventing people from falling from heights. We do have on the security burglar resistant, bulletproofed, and blast resistant, but we do also have combinations thereof. So we do have 100% sister company, it's called Seltzer. They do all sorts of very high safety and security applications. Yeah, now pre-construction service, what is it? What do we do? What do we provide? It's actually a service the company provides in order for specifiers, architects, building owners to get into position to make an informed decision. Now, how do we do that? First, we listen and connect to the people. Why do we do that, and why is that important? Because we do want to understand where is the intent. What is the intent of the designers? What is the intent of the owner? The third part would then be we're going to see where has been reached already in the design process, and then last we would provide our input, where we think we have an value addition, in order to not happen what is on that slide, that two people are talking about the same, yet not the same. Now, how do we apply that? There is the pre-construction service. There is a project, and you can see at the bottom corner, there is a iconic scoop, as we call it. The designers wanted to have that scoop because obviously iconic. He wanted that to be an iconic feature. He wanted it to have to be modular. His understanding of modular at that time was only unitized. So his understanding he wanted to have a unitized curtain wall. He wanted, therefore, the transition between all the units in the scoop to be smooth and obviously cost effective. The site was there. So there we should apply. Now, as I said, we listen, then we pick up people where they are. In order, if you want to make a curved, double curved design, there are various ways. Now, we need to manage expectations. So one way is to make a unitized curtain wall, and then you can either roll the profiles, you can hot band the glass. Obviously, that comes with cost. So now there's another way you can do cold bending. Cold bending has some limitations. Means if you go over certain limits of cold bending, you would have to have offsets. Now, this is just to show the architect, the designer, that is what can happen. So if you want to have it rolled and hot bend glass, then it will be probably not as cost efficient as you wanted to have it. If you go for the cold bend, then you would have offsets. Is it that what you want? The other solution could have been, what we also did is to make it in stick curtain wall. Obviously, you would get kinked brackets. You would have double brackets, because if you have kinked offsets, you need to have 2 brackets per floor. So not cost efficient, and as well not unitized at all. So, but what if we would have a system that is parametric, a system that is versatile, a system that is out of aluminium, so can be recircled into the process over and over again, that gives you freedom of design, is easy to fabricate, also easy to install, because it can be pre-assembled, therefore cost effective. What if we would have a system that would allow us to go from the grid lines of the designers to the structural shell of the engineers, from grid to shell, G to S. Now, we do have that product. It involves, obviously, a certain process. The process is that we design, we model, and then thereafter we generate. We have seen from Ben's presentation, but also from Giovanni's presentation, you have seen how this grasshopper type of things works. Obviously, something similar is applied here. And once we have the mesh created, we do the modeling of the components, and then that whole thing goes into the structure calculation in parallel. Parameters are changed. So the striking thing about that product is that it has very limited components, yet it allows you to give you freeform and 3D construction. So it basically has 2 aluminum components, which are the rafters and the nodes. Then the rafters are bolted to the nodes, and then on that rafters we have our EPDM gasket system that can be trained. The glass comes on top, and that's it. So what we have done is basically the traditional way of, if you would do something like that, which is a steel with an add-on construction, where we have combined basically this add-on construction and the structural steel into one extrusion. And then the nodes are milled out of a solid piece of metal, in our case, aluminum. And you will see then what are the advantages of having it in aluminum. Because it is milled out of aluminum, it is a very high precision product. Now, if we compare steel with our aluminum system, what strikes you is, first of all, we can create this, what we call star nodes. And the other thing is that the quality of the nodes, however the shape and form of the node is in aluminum, it would all be having the same aesthetics. Now, even there are where you can't distinguish where is the node, where is the rafter. It can be powder coated, so there is no painting on site. And yes, the whole system has been extensively tested. It has been tested horizontally and vertically. Why is that important? Because a system that has been tested horizontally does not necessarily need to perform in the same way vertically, vice versa. So therefore, it is important to have those types of systems tested in both applications, which we have done. Now, about sometimes people then would say, okay, but it's aluminum. Is it? It's light. Is it stable? How? Yes, it is. In the end of the day, it is a matter of structural calculation. It's a matter of the input that we put into our models. Here you can see during installation we put in additional loads, maintenance loads, and so on. Now coming back to the scoop, because this is where we started, and this is where I wanted to explain how did we apply our pre-construction services. So keeping in mind what the architects, the designers wish was to have it iconic, modular. His understanding was unitized curtain wall at that time. It should have been smooth transition between all the units in there, and should be cost effective. We asked, okay, can we provide something in our G2S? He said, yes, please, feel free, go ahead. And this is what we presented to him. And yes, you see that the verticality of the scoop has been engineered away. However, it has been something created, something new, and the architect liked it. And so, in order for him to see that he's not a guinea pig, there is projects where we have applied that system in a similar application already. Another project was here where we asked, okay, Thomas, we have two-floor curtain wall. It is parametric. What is the solution? What can we do? And I said, okay, yeah, principally 2 floors, you go with your stick curtain wall. However, if you want to make it 2 floor, you need to beef it up, because aluminum as such, is very, you cannot span it 2 floors. So again, we provided a solution in our G2S now in a vertical environment. And why was that important? Because the time to from finishing the design to coming to site was given with 12 weeks only. So yes, we needed to have something that is also pre-assemble, that you can pre-assemble. And yes, we have done some projects in that as well, in that vertical application. Another project is where speed was the key, because it was a shopping center. The client wanted to have 8,500 square meters of skylight. He wanted to close that as quick as possible, because so that the interior fit out could start. Now, his initial design, it was with rectangular glasses. And his initial design was quite something traditional with steel girders. We had ropes, tension rods below that. Now, it's nothing about the design, of course, but having in mind that the client wanted to have that skylight, 8,500 square meters, closed as quick as possible. Just think about the installation sequence of that. You would have to come with the steel, you would need to come with your tension cables, you need to align, then you come with the AOC, then you come with the glass. So we said, okay, can we propose something in our G2S? And that is what we did. We proposed it in G2S as a, let's say, with rectangular glasses, without the need of having any post-tension cables. sorry, without having cables. And then we also gave him the opportunity to have the thing in triangular glasses. Yeah, now that comes to the advantage of the installation, because usually if you do steel, what you would need to do on an application like the before, you would need to have a temporary platform, you need to check it up, and then from that working platform you do your installation. Now with our aluminium grid-to-shell product, because it can be pre-assembled in parts, this is what we do. So we assemble parts of 200-300 square meters. The biggest part that we have done is was one dome, a little bit short of 1,000 square meters, which was pre-assembled on the floor and then lifted in place in one go. So, and by doing that, by having the ability to pre-assemble, we can close quite vast areas in a very short time. You can see here that if you just multiply that. So what can we do with our G2S? So what can it be? It can be a skylight. It can be a small skylight, a dome. It can be a vertical facade. We have seen that. It can be everything in between. It can be everything in between a facade and a skylight. So, and that without the need of having any support system, because it's self-supporting. Yeah, that is what the advantage of that product is. Now, the last, the almost last project I wanted to show you is where we applied the G2S on a. It was an architectural feature, cum shading device. And what we had to do there, because just bear in mind, it was primarily developed to be a glazed skylight. But what our engineers did there, they took our facade system, which is the fabric system, and then they combined our facade system with the grid-to-shell system and came up with a new product which allowed us to create this completely free-form structure, yet shaded. And as I said, you know, it could be prefabricated. In that case, it was the support system was steel tree columns, which we also did as part of the design, because when we do the design for that system, we have to ensure that all of our reaction loads are actually going back to be transferred to the loads, to the building. Yes, so shading features, yeah, and yes, something you might not be necessarily thinking of. It can also be done as a bridge, walkways. We have done that as well, and it gives you a very high aesthetic, because it is, as I said, you know, it is aluminum. It can be powder coated. There is no messing around with painting on site, no welding, nothing. We have done spans of up to 70 meters. And the other advantage is it's a local product. So this product, the components therefore are made in GCC. So we are quite fortunate to have it here and having very short distribution ways. Seeing is believing. We have our star sample outside at our booth, and I'll invite you to come and visit us. And yeah, that's it. Thank you for listening.
Is the The clicker is stuck, right? Okay. Well, thank you very much for the introduction, and boy, does it feel good to be up on stage again after this hiatus of the pandemic. Ahad and Amro, thank you so much for inviting. It's always great to be here and being inspired by all these presentations that are, eye-opening to us. What can be done here in the Kingdom of Saudi? I've never been here. This is the first time, so it's really exciting for me to see some familiar faces, but also a lot of new faces. So great to be here. So my name is Christoph Timm, and I'm an architect. I stress this a lot because I don't want to be a facade guy. I don't want to be a project manager. I want to be an architect, full-blown, wide spectrum that I'm working on. And so is our firm. I put this black and white image here of our founders on the screen. Skidmore, Owings, both architects, were joined by Mr. Merrill, who was an engineer. And that was in the 1930s in Chicago in America. So we've been around for 80 years. And in the DNA of us is this interdisciplinary practice idea that together various disciplines can do better jobs than just siloed architects, siloed consultants. And so working together is very, very important. And I think our architecture really shows this. If you look at some of these projects, the Burj Khalifa, heavily the design driven by structural engineering, by the wind loads. That's why the building looks the way it does. So the architecture becomes part of the structural engineering. The Hancock Tower on the right in Chicago, same thing. We didn't want some cross bracing here. We didn't want to have some aesthetic axis here. This is cross bracing of the building. And so really the architecture again follows the structural engineering. And lastly, the Broadgate project here in the center in London. It looks like a bridge, it looks like an arc. It is an arc, and it's spanning some rail yards underneath. So the building is a bridge, and you can really read this. And we think this is the best architecture that is very, very efficient with material, saves on material, and makes the architecture as light as possible. We're a company of 1,200 people, and we're working across the globe. And by now, especially after the pandemic, we're becoming a one firm. Teams are collaborating across the world, and it's in kind of an interesting way to see how the pandemic helped us achieve this goal of working together. We've been in the MENA area for a long, long time, since the late 50s. We've done work. In the 80s, we had a lot of success here at the Hajj Terminal, for example, the National Bank in Jeddah, and the joint banking in Kuwait. But lately, we've also had a lot of work here, over 200 projects since the 50s. Burj Khalifa, and not far from here, the KFD Conference Center, the Alhambra project in Kuwait, and the Four Seasons in Bahrain, for example. So we know the area, we've been around, and now we're coming more and more with an increasing portfolio of projects to the kingdom here. You can see some of the projects that we're working on. And I'm going to talk about two specific projects today, the Avenues project and the Jeria project. There's a lot of more projects that we're working on, but those are the ones I want to focus on. We understand that the most important thing is boots on the ground, making sure that the design that we've dreamt up, came up, engineered, is really implemented. So we're making a huge effort to being really on site and seeing what is being built, follow the design all the way through. Right now we're headquartered in Dubai, here in the Middle East, but we will be opening an office in Riyadh next year to be even closer. We have other personnel right now on the ground that's following the projects, wherever they are, but we think it's time to really have a permanent basis here in Riyadh. So it's going to happen next year. So this is a facade conference, and the title was Sustainability and Safety. And I thought I'd focus a little bit on the sustainability aspect of this. We all know, scientists tell us that the atmosphere is warming. And so unless we do something about this, and Werner Sobeck spoke about this in his little video, unless we do something about this, we have a really big problem. And so how did we create this? Mankind over the last 100 years has put so much greenhouse gases into the atmosphere, that the planet is warming, and we got to do something about this. We have to not just cap the output, we have to bring it down significantly, probably by 80%. So why does this matter to the construction industry? Well, we have a significant part in this. About 40% of the greenhouse gas contributions are from the building operations and the building material construction sector. So both of this is in our all responsibility. So we have to do something. Well, so how do we design a better future? And that I wanted to talk about. Enclosure performance at the very, very top of the list. If we get the enclosure performance right, if we get the massing right, if we get the orientation of a building right, a lot of things will fall into place, and we can engineer our buildings with smaller mechanical systems. We have better daylighting and a lot of other things that will make our buildings much, much better in the future. So enclosure performance and the nature of the facade is key. We've been pretty good at controlling the facade performance during the service life of a building. We've been bringing down operational carbon that the building uses during its service life tremendously over the last 20, 30 years with fantastic new glass technology, coating technology. So this has been on a radar for a long, long time. We have our limits of our targets where we want to be with our facades, individually different for the type of project, wherever the project is, so we know which way we need to go besides all the codes. However, you saw the slide earlier that a significant part of the carbon in the atmosphere is generated by the construction of buildings and by end of life. So we call this the upfront embodied carbon here on the left, before the use of the building, and then at end of life, you still have to put in some energy to get the building basically deconstructed. And both of these, we have started to measure, and in order to measure and then compare it to some standards that we want to meet. Same thing here with the embodied carbon, and this talks about only the construction before the service life. So we have our targets here that we're trying to meet to control it, because unless you measure it, you don't know where you are. SOM is 100% modeling, energy modeling the operational cost, and we are trying to do the same with the embodied carbon. We're not quite there yet. Only 80% of our projects we do this, but this is our goal, to do this 100%, to really understand what the cost, what the environmental cost of our buildings is. This architectural conference. So again, I wanted to bring some facade studies, some case studies here to the group here. Buckle your seat. It's going fast. We're going into Manhattan, a project brand new in Manhattan West. It's a new neighborhood in the city. And I want to talk about the Pandry Hotel, which is this tiny little black building. Well, it's 21 stories tall, but next to neighbors that are like 70, 80 stories tall, it looks very tiny. And also the footprint is significantly smaller than its neighbors. So how do you make this building something really special, a jewel? It's a hotel, you really want to attract hotel guests. So we came up with the idea of making this, we're trying to make this a sculpture, a monolith. And you can see there's a lot of glass on it, and the glass is kind of rippling in a convex, concave shape. It's separated by some spandrel material here. And it really makes an impression as you walk on the street and you look up, you can see this. Really makes an impression, I think, on you next to its tall neighbors here. And it works perfect, this rippling, because it's a hotel, and the idea of a bay window was very attractive to us. So imagine yourself sitting in the bay window there, looking out, and being engaged with the environment here. What a beautiful thing. The rippling also continues in a very modern way all the way to the base. We have a stone podium where all the mechanical, electrical equipment is in, and then a little lobby, of course, at the bottom. Nowadays, the delivery of buildings in New York is oftentimes design assist. That means like we don't go out into the marketplace after construction documents. Way earlier this happens after DD usually, and then you develop the facade details together with the facade contractors. We met here weekly. Floor plan, typical floor plan here, 11 keys per floor, and a lot of opacity. And so what you see here on the in red is opaque panels that basically have much better insulation values than the glass. So window to wall ratio is key also to bring down these energy costs, energy usage numbers. We try to make the geometry of this building as efficient as possible. We ended up with only 3 different radii for these for the ripples. And then, of course, that helps with the glass production and the stone production, having only 3 different radii generating all this. You can see the vicinity of the Empire State Building here, 33rd Street. And I started talking about embodied carbon a little bit earlier, and that we are measuring or we are calculating embodied carbon. And so here I wanted to show you a sample study of stone material here for the spandrel, for the opaque areas of the facade other than glass. And we wanted to compare how much is the impact that a stone panel would have compared to the impact a UHPC panel would have, compared to the impact that aluminum would have. And here in comparison, you can see the winner is the stone. Stone had the least amount of embodied carbon, 249 kilogram equivalent CO2 per square meter of facade. And so that wasn't the only reason why we went with stone. We loved the stone from an aesthetic standpoint, but this also helped making the decision that stone seemed to be the most efficient in terms of energy. You see the typical detail here of a stack joint. It's a unitized curtain wall, and we wanted to add a little bit more to the stone. We recessed some areas here, we machined them out. It's flame finished, and I wanted to show a few pictures of how this was built. After quarrying it, the big blocks are cut to pieces, to smaller pieces. Then it's flame finished. It's cut with a bandsaw, interestingly. So it's not cut out of a block, each panel. No, it's sliced like a potato chip, one after the other. So it's very efficient in terms of material usage. We're cutting it down to the panel size, putting in the grooves, running it through the water jetting machine that creates this beautiful finish here. You can see the slots are like machined, and the other areas are flame finished. QA/QC, very, very, very important, especially nowadays. We're seeing a lot of differences in stone finishes, in paint finishes, in aluminum finishes. So we are really learning that we need to QA/QC all our products more and more in order to come up with the facade in the very end that is homogeneous and beautiful, and we don't have any outliers. So we do these dry layouts here for the stone, make sure every panel is the same. We run through the typical visual markup process, inside, outside, test different pieces of glass, benchmark the glass, especially when you have curved glass, you have to worry about anisotropy, quench marks, things like this, making sure it's visually pleasing. The glass we used is a tinted glass here, as you can see, and we've learned that tinted glass, obviously, it hides a lot better what's going on behind the facade, meaning like it could be there could be opaque areas, and the idea of this the sculptural effect without seeing like all these patches on the facade led us to go with tinted glass. A few pictures from the panel assembly at the curtain wall. Fabricator tested it at Intertech, who's also here. And typically we build like these performance markups with 3 layers and run the airplane engine and test it for water tightness and air tightness. Some pictures of the installation, typically in New York, concrete construction. Oftentimes we see these anchor details in the pocket. We have these mobile cranes usually that install these units that are staged on the floor below, then brought out and hung, as you can see here. These pockets are filled. Very important. I'm hearing also in Saudi, making sure smoke and fire seal is installed between the back of the curtain wall and the slab edge. And this is how it looks at the very end at night. So we think like a very warm atmosphere that this facade has here. Again, buckle up. We're going away from New York City. We're going to Cambridge, Massachusetts. And it's a complete different project. As you can see, it's a freestanding project. It's a federal research headquarters, and we're about to finish it. It's almost done. And so it's a freestanding project. It's kind of dominating the area. And so we wanted to take a much different approach here. Here we wanted to be really pushing the energy consumption. And therefore we came up with a facade design that reflects the exposure of the building. Towards the north, maximum glazing at the tower section you can see. We get the ambient light as deep as possible into the building. And on the east and west, vertical fins that reduce the solar heat gains. Here in plan, you can see it. At the top is north, flat facade, left and right, east and west, simple aluminum fins, and then vertical fins. And then on the bottom is the south facade with overhanging self-shading elements. In summary, direct north, south, and west and east, and you can see the savings that are generated by these simple fins out of aluminum. Not that it helps with the performance, for sure, the energy performance of the building, but also the comfort. We heard about comfort, human comfort. It helps with the glare a lot too. Brings down the glare levels. Red is glare in all these diagrams, so the bottom row is with the shading, and you can see that the glare is much better than before. A rendering, and this is how the building looks. So it's pretty amazing also like that the renderings are so similar to reality nowadays. You can see a unitized system here, unit here in red of the east and west facade. The fin is made out of aluminum. Very machine-like, very precise, very tight. And then the south side with the overhanging fin that is very, very similar, constructed like the east and west. You can see still the hoist from construction from a few weeks ago, but it's almost done. And same thing again here. We looked at the embodied energy. And here it's an interesting thing. Previously, we compared materials. Here we compare the exposures. We compare the south side to the east and west. And you can see a significant difference, 308 to 588. And so where is this coming from? Well, it's coming from the aluminum in the fins. Aluminum is a high-intensive energy material. So because of these fins are so much aluminum, we have a lot more embodied carbon in the east and west. And so we're learning right now that this balance between getting a high performance operational building versus a low embodied carbon building it's a balance, and we have to play with this balance. So this is all new to us, and so I encourage everyone to just jump right in and just do it. Even us, we're beginning to learn this only right now. Now we're coming to the kingdom, and I wanted to give you a little bit of a sneak preview of what we have been working on here and what projects I can talk about. The Avenues Riyadh project here at the intersection of King Salman and King Fahd. It's under construction right now, the project, and we worked on it. We won a competition, I think it was in 2015 or so, went a little bit on hold, got going again. In 2018, we submitted SD, an SD detail, SD set. It's basically 5 towers up to 185 meters tall, but it went on hold. And we had to come back in 2022 with a new set of design ideas because it didn't pass the critical eyes of the Royal Commissioner. We had to go back to the drawing boards and see what could have been done. And you can see that the facades have slightly changed, the color has changed, the usage has to some degree changed, so it's commercial, it's residential, it's hotel use on these 5 towers. And the reason why we had to go back to the drawing board is basically Vision 2030 from Saudi Arabia. And part of this vision is also the Salmani architecture guidelines that have to be met by certain projects, not everywhere. We've been learning. And I thought it's worth talking about some of these main principles that are in the Salmani guidelines here. It's these 9 principles, and we had to address every single one to some degree to get acceptance by the Royal Commission, which we did get, and we are expecting the project to progress next year with an SD phase. But let's walk through the various phases, various principles. You can see here our approach to item number 1. We try to have on an urban scale a slight variation of the material color. What was previously more whitish, more cold, is now much warmer. It's more desert-like, the sand, and has a gradient from tower 1 to tower 5. We had to specifically address energy usage and how to deal with a harsh climate. And on the top here, you can see a diagram comparing having a project without fins versus a project with fins. And you can see the darker the color, the better it is in terms of heat mitigation and bringing down the solar loads inside the building. So all 5 projects have a lot of vertical fins, which is desired by the guidelines. On the floor, on the ground floor, the interface between the building and street has to be looked at carefully. And so specifically, we have a lot of canopies, a lot of like carefully designed spaces, as much as they can be during a conceptual stage. But big focus on having this, having a smooth transition between the inside and outside, making this very attractive. You can see where I talked about the color change, and also like the change of like the simpleness of the structures. You know, before we had like a shape at the very top, at the crown here, and it became a completely just extruded expression, similar to this reference image from the guidelines. We also gave up some of the more specialty features at mid-span here of the buildings and at the crown, and made it to the top right here, a calmer design, a simpler design, which is desired by these guidelines. We had to work on the window-to-wall ratio to bring it down, desired by the guidelines, 30 to 50%. We are dead in the center of 40%, and that is like the average from the very bottom to the very top. Another idea that we show here is towards the bottom, it's a much more opaque building, and as you go up, it becomes more transparent. And you can see this in all of these schemes. And another thing is that the facade is also broken up into 4 different segments, again, very subtly in some of the schemes and more apparent in others. You can see the separation, the vertical separation. There's a desire for sober exterior, a single material, and so we're trying to work with single materials on the facades here. Here, just some reference images. Bottom right is Alhambra in the Kuwait, for example. And yeah, but again, very natural colors, inspired by traditional geometries, inspired by local technique and materials, lots of stone, truncades, brick, and I'm hearing terracotta could be also an option. And this is how it looks in the beginning. So we as SOM were, in the end, we as SOM were responsible for the 5 towers. Others were responsible for the lower part of the buildings, for the podium building that you can see that's filling the entire site, except for the front here facing the highway. And that is almost it. It's under construction. There's a lot of work going on, I'm hearing. This is not the latest, but you can see, yeah, lots of concrete being poured here. And this time we don't go very far. We just go down the road a few blocks to the Jaria head office that similar story, won a competition 7, 8 years ago, and it went on hold and started up again in 2020. And we delivered a DD package this time in 2021, and again put on hold because of the commission, the Royal Commission, and we had to go back to the drawing board. But first, this was the original scheme, all precast, with a lot of activity in the glass and the facade is going back and forth, and I think it was just too loud or too noisy for the commission, and so it was rejected. So some nice moments here on the. This is the south side at the center of the project. You have double height spaces screened in, which protect some of the neighboring residential properties from too much exposure from these central meeting spaces, which are quite nice. You can see the screen on the outside, and you can see the double height spaces in the middle. So this is how it looked in 2021. And then, yeah, part of this 2030 is for Salmanian guidelines. We were sent back to the drawing board, which is, I think, in hindsight, a blessing in disguise for a lot of architects to look back at the work that we've done or they've done, and then analyze whether this was good or was it too quick. And sometimes it's good to reflect. And in this case, I think a lot of things happened very quickly, and it's good to go back and reconsider what do we try to do here. And to be honest, vernacular architecture, regional architecture is so much more successful rather than taking like an international style building and plugging it into some neighborhood that has relatively little to do with it. So I think in this case, it was great to slow down the process, to understand really what we want to do, and had to go through the redesign. So this is just recent, like a few months ago, the original submission, and then option 1, we came up with a system where we have, we create like a double module, and then a very, very vertical facade expression as another scheme. Both of these schemes respond to the Salman guidelines in terms of color, in terms of material use, and these diagrams at the top right here and the bottom right are taken straight out of these guidelines, and you can see that, how they work here. What's not allowed as per guidelines is very reflective glass, or opaque glass, mirrored glass, all not acceptable, and it's desired to have more a neutral glass expression. I think, as we heard earlier from the gentleman from Guardian, low reflectivity and high performance glass is desired. This is the scheme number 1, and you can see like we toned down the glass. The glass is not like it all points in the same direction on each facade, so it's much calmer. Kind of a nice solution at the corners here, and this is how it looks, much calmer. And scheme number 2 is a little bit more responsive, similar to the federal building in America that I just showed earlier. And here we have different exposure. On the different exposures, we have different facade types. Towards the south, much narrower windows. Towards the King Salman Road, much wider windows. And on the east and west, we have protection with vertical fins. This is how it could look like. It's all concept. You can see the verticality here. And this is how the 3 schemes look compared to one another. And with that, I want to end my presentation, but I didn't want to end without saying something in general. I started talking about embodied carbon usage of our buildings. We as architects and engineers, we really are testing the water. We really trying to understand this. This is not easy. It's like an airplane that you build while you're flying. It's very difficult. And we as architects and designers can't do this alone. We need owners, we need facade consultants, we need everybody who's involved in the construction industry to be on the same page to achieve these dramatic goals that we really have to do if we really want to have a future. Thank you.
Until 1:45, so we've got till 1:45 to do lunch. So you're invited back at the back of the room. Thank you so much.
Thank you, Bert. Thank you. So I have to wake you up after lunch, yeah? Thank you for the invitation again. Thank you to be back. It's always good. And I say again, I'm here since Friday because I have relatives here. And I love to spend in Riyadh now the time smoking shisha and going out on the road. The weather is super. I mean, Riyadh changed so much. I love it, to be honest. So happy to be here. We are talking about sustainability and safety for sustainable for targets together. What I want to focus on the first part of my presentation is about the word together. Christoph, you said at the end as an appeal to the crowd, you need us. I think we need even more. So I start with a quick introduction who we are. We are German facade consultant engineers since almost 30 years. Next year we have 30th birthday. We do plenty of projects in Germany, in the US, in Asia, in the Middle East, and of course in Saudi Arabia. Was happy to hear from Amrania. We are working on one of the Western stations for the complicated glass and some others. So there is some experience in the market. This is what is our global setup, basically. And interesting thing is more than 50% of the global group is basically servicing the MENA region. What is maybe interesting for you is that we're serving each and every client who is related to the facade fraternity. So from the core, we are facade consultants serving investors, architects, and developers, but we are very close to main contractors, to even cladding fabricators, and I will come to this point later. And we are also very close to the facade industry, like the suppliers, universities, and institutes. We are servicing each planning stage. It does not matter if we are talking about pre-tender, construction phase, in use, or on strategy matter, and I will come back to this topic after I show my presentation. So first part is local production and local infrastructure. Ben, you gave some very good examples today about learning from the past. I have some similar slides about this topic, and we have very good examples in Saudi Arabia that this happens. I mean, the construction is massive in the country, but we can see some very, very careful, crafted work to be designed in Saudi Arabia. One of the examples I'm showing, this is a video basically from available on YouTube. This is a design done by Jean Nouvel on one of the hotel projects in Al Ula area, where they are planning to really craft the facility out of the existing rock. And this video is amazing. We proposed this project, and the design and the ideas behind is yeah, breathtaking for me. So there is some understanding in the country about respecting the past basically and learning from it. But looking to the huge scale of the projects and looking into the past 2 years, I think we all experienced the restrictions we were faced when we were not able to travel. Goods restrictions, we are still struggling, even in Germany, with supply chain situations. And this is something I think we have to think about how we face this together. Local sourcing would be very much important. The Salmania guidelines are focusing also on this matter, and we understand and when we respect this. And something much more important also I want to point out, we are in a market here driven by leaders and visionaries different to other parts of the UAE. I mean, I think other parts of the Gulf. I think we are used to innovations from the UAE, for example. But what is here driving force is a different strategy. And there is a very high expectation on what basically has to be delivered. And we have to understand this. So collaboration and knowledge transfer is vital. And I think such a conference is one of the reasons why we are here, why we are talking about a collaboration and how we can work on these things together. So the second part is probably more talking about the sustainability and safety, how we can bring this together. We had huge examples today about what to respect in designing a building. Life cycle approach is something we are very much used to, and Christoph, you gave a big insight of what you understand of a life cycle. This is extending to a way even, let's say, before what we understand in the past from a life cycle, so we understand this. Sustainability is a wide range. Is it green or what it is? So of course, facades has to be sustainable. CO2 reduction, we also got a lot of insight in this. We are working, especially in Germany, on the matter of cradle-to-cradle principle. There is a lot of efforts getting into this. We are probably the world leader of certifying whatever we can certify. Now, when you rent in Germany, you get the same rating of your rental property than you get for a refrigerator or a car. And not to forget digitalization. The digitalization, we heard about BIM today, will definitely drive and support future maintenance. So everything, and last but not least, of course, user comfort. We want to live in these properties, and this all need to be respected. But as I mentioned before, what also need to be respected when we are here in Saudi Arabia looking into the mega project that's coming up, there is a vision which I think one or the other of you, when we see this, we can hardly believe it. And only once you touch the papers in your hand and you see you are really physically working on this, this might gonna be built. And this is something we experienced over the years. The expectation, especially here in the country, on things are built the way they are designed is very high. So there is a force driven on a vision. There is something sold to the decision makers in this country. And when we are part of the team who realize this, I think we really have to put the focus on that it is getting delivered in this way, and we have to design it in a way that nobody can change this on the way, basically. So this all happened with a certain local condition given, and I think it's important to respect what is locally available and to collaborate, to upgrade this in a certain way. But I have to say, when we look to these mega projects, we have to be clear that capacities and capabilities are probably very rarely available in the country. So the collaboration to realize these things is really essential. What we are doing from the past already to support is factory layouts support. So we are designing factories who can manufacture facades. As we are since 30 years in facade, we know this. So recognizing what capacities are required, planning procedure, optimizing the workflow, up to consultancy of the staff, the overhead you need, the machine supply. This is an example many, many years ago when Burj Khalifa was built and the original facade fabricator went off the project. The new facade contractor needed to design a factory who can manufacture 250 panels per day to catch up the schedule, and the factory was designed by Priedemann. So we are really on the ground. We are people, 60% of our project managers coming from the fabrication background. So we are coming to the factory, we show how things getting built. We do quality checks and management, and we do real support on site, how things can be solved. So we are not stopping in designing stuff, we are really helping to realize this stuff. A few quick examples of how we realize this. Usually I don't quote, but this is an interesting quote. It's not only about the ideas, it's how to make it happen. And Behance is one of the platforms which makes things happen, not on the scale of our construction, but it's, I think, crucial for artists nowadays. So it's a good example how make things happen. This is one of the projects we did, NPP Control Tower in Doha. We were on the architect side for the construction phase, and the building was designed to be curved in a certain way with an open tender, how to solve the matter. We explored already cold banded at this time, but we kept it open for the decision of the fabricator. But later when the fabricator was assigned, he took us on board and we went back to the matter of cold banded, and the result was basically that it has been done up to a scale that we designed the tables where how you bend the glass in cold, and the elements. We did the testing together, and the project was successfully installed. Unfortunately, not many people can see it because it's on a closed port, but it's a fabulous project, very successful. Another project where we were working on, this is the headquarter of Russia's biggest copper mining company, designed by Foster & Partner. We were also on board of the architect. A project with huge element size. The unitized curtain wall is 6 meters high and 10 to 12 meters 6 meters wide and 10 to 12 meters high. You see the scale of a person for one element. And we did the design from paper to all done in SolidWorks in this case, until 3D printed. And the interesting stuff is probably at this time where Russia could not buy the facade anymore in Europe because it was too expensive. They hired us on the owner side to set up a factory on the construction site, a temporary factory. And here you see the welding robot running for the main steel structure. This all is programmed and designed in Germany. We just sent the files to the client, and the welding robot is running based on this. And this gentleman on the right side had nothing more to do than just control, and everything is getting reworked. This is the assembly and the installation, and it is successful. You may look on YouTube. It looks from outside already stunning, but if you see the pictures from inside, it's just breathtaking what they built there. So successful collaboration on the ground up to the last screw. What is waiting for the future? A quick outlook. We believe facades should become adaptable. In the past, we were putting a lot of effort in reflecting energy outside. This is the headquarter of ThyssenKrupp. The price of this shading is 1,800 euro per square meter without the facade behind and without the material costs. Then it became adaptive. Good example also on a facade. Now we are creating facades which embedded power plant. This is the new headquarter of the Dubai Electricity and Water Authority, right now under construction. It will be the world's biggest net zero energy building, and Priedemann was designing the facade, and I think, Agnes, you control that it's getting installed. We are working on energetic panels embedded into the facades, where you can easily exchange a piece of glass to a solar panel. We are working on a product which is a solar thermal panel made of UHPC. We are working on a plug-and-play solar integration and on even Venetian blinds where solar cells are embedded. So a lot of things are going on in creating energy into the facade. And this is the newest baby on adaptable facades. We're working with shape memory alloys. This is basically a special alloy which you can design based on the temperature you want the material to react. And then in the best case, it is reacting autark to changing the temperature in the environment, or you can also put it with an electrical impulse. And this is the Adaptec wave. So imagine the sun is shining on your facade and it is closing the, like an eyelid, it is closing the facade. The second version is the mesh version. The same happened basically. The mesh is moving based on the temperature impact, and it is closing the facade. And once the temperature is getting reduced, it will open it again. It's fully functioning. It's now installed with a cooperation university in Oman. So it's now tested under real climate conditions. And soon we hope we can see the first projects in place. So we believe the future is in a certain way adaptable. This is also an adaptable solution which we created. This is running in Germany. We are waiting for the first project in the Middle East. Basically, it's designed in a way that your second skin of the facade is not in the exterior, but it's the interior. The inner blind is basically moving down when you need a glare control, and we start to exhaust the air into the gap between the glass and the blind. We believe a very, very good solution for the Middle East, because you anyway need blinds. A system developed with very, very capable partners, one of them, by the way, Schuko. So this is a ready-made system available. Another idea, it's a concept not yet set. We won a competition in the US. It's called Metals in Construction. They always give a real existing building, and then they announce a competition in the market how to bring a facade solution for this building. And Priedemann won the first prize with a concept of a kind of a facade system where you have functional primary layer, functional layers and secondary layers, and you can change the exterior of your facade for whatever you need and require with the change of the buildings. The background is, if we look into the housing situation which we have in Germany and the challenge we have globally for houses, a certain standardization is required, and every architect hates standardization. So in a certain way, we believe that what we need is a standardized variety. We need to create a standard system to be able to be faster, cheaper, more adaptable, but at the same time, it should give a variety to the client. We are proposing it to many clients globally. We wait for the first solution, and I personally dream that such a system could be adaptable maybe for such a giant project like the line. Huge facades inside, we are not talking about even outside facade, while the outside seems to be something same everywhere. Inside there is a huge variety necessary, and it would be impossible to make this all with individual facade solutions. One word, and this comes back, Christoph, to your plea for a collaboration. Yes, you need us, we need you as our clients, but I think we also need the authorities. We are in a situation where we are on the way to raise capacities in the country in terms of fabrication, waiting for the giant projects to float into the market. We need to look careful with the authorities on how this is a successful launch. We all saw what happened, for example, after the first phase of King Abdullah Financial District. Many of us have experience from the UAE, what happened when capacity is getting up and then the market is slowing down for whatever reason. There are so much giant projects that we need to join force to collaborate and realize it successful. And this is coming back to the circle I showed at the beginning. So we are supporting each and every, let's say, stakeholder in the building facade. We call it, we close the loop. We have a continuous support, or better to say, continuous responsibility. So we are ready, and we raise the hands for collaboration to realize what is coming up for Saudi Arabia. Thank you very much. I saved you 2 minutes, Bert. Thank you.
Thank you. Thank you, Bart, for the introduction. Good afternoon, everybody. My name is Scheers. I'm the Sales and Market Development Manager and Technical Manager for the Middle East and South Africa for Kururai. I want to quickly tell, for those who don't know Kururai as a company, I know most of you people know us, but for the people who don't know us, Kururai is a Japanese chemical company, founded in 1926. So we're very close to celebrating 100 years of the company. Our division is actually producing and supplying interlayers for the glass laminated market, for the architectural market, which most of you are mostly interested in, but also for the automotive industry and for the transportation industry. We have facilities in Germany, in Czech Republic, in the US, and in South Korea. These are the products we are supplying in the market. It's a wide range of products which are designed to help you in designing your facade or your building. Today I will focus on this short speech on the acoustic interlayers and on the structural and security interlayers. There's many more that we can supply and help you with. We have a table outside, so after the speech, if you're interested to get more information, please pass by at our booth and we can answer any questions you might have on our products. So security glazing, they are required for mitigating the threat to the loss of life and property. They are man-made, or they are sometimes also natural threats like hurricanes and tornadoes. Apart from terrorism, glass facades are the soft target for any attack, because the trend is that the windows need to be bigger and bigger, but that also means that the window is the weakest part in the whole design of the building. So what we are looking for is to make the windows more strong and to protect them from any event that might happen, whether it's a man-made attack or a natural event. So the framing and the glass needs to match well to perform in a good way to make sure that whatever is inside of the building is protected from any threat. So security hazards for man-made threats. From the left-hand side, you see forced entry or exit, which is typically your robbery or theft of property, riots, terrorism. It's valid for residential, commercial, and public sector. Escape from prisons is something you might not think about, but also in prisons, the glass is designed these days to prevent people from escaping from the prison. Displays also are damaged frequently in riots and thefts. Firearm attack is the second part in man-made threads. It's also valid for residential and commercial and government buildings, banks and jewelers as well, and armored vehicles is another section of the bullet-resistant glazing market that we are supplying our product to. The third one is bomb blast and explosion. Usually it's for high security sensitive buildings that the glass is designed to resist a bomb blast. For terrorism sensitive areas. Public transportation also sometimes is designed to resist a bomb blast. And also hazardous processes and material storage can be designed to resist, again, bomb blast. A little bit about the basics of glass. The primary glass is just the annealed glass as it is produced on the float line. If this glass breaks, it breaks in very big pieces. And in the event of a bomb blast, for instance, if you have just an annealed glass, there is big shards of glass which are flying around and causing actually the most injuries and deaths. I'm going to the second phase of a more secure glass. You have your tempered glass, which is shatters and breaking in very little pieces, which is causing less threat than the traditional annealed glass, but still it's not a very safe glass. If you have a laminated glass, your interlayer will protect glass shards from flying away from the laminate. So all the pieces will stick on the interlayer, and this will be the ultimate safety glazing. So this is exactly how it's made, 2 pieces of glass or more, with an interlayer in between, PVB or Sentry glass. There is other interlayers on the market, like EVA, polycarbonate, and polyurethane, but I will focus on PVB and Sentry glass in this presentation. So for the security hazard, the forced entry, there is 2 types of norms in the industry. There is the norm for the glass on itself, which is testing actually the quality of the glass against forced entry. And there is also a norm testing the frame together with the glass. There is European norms and there is US norms. In this video, I will show you, this is a jewelry cabinet. The first part of the movie will show you a normal laminate with PVB, where you can see it's very easy for the guy after a few hits, he can make a piece in the glass and he can enter quite easily. The second part of the video is a structural interlayer, a Sentry glass, so it will be much more difficult for the guy to make a hole in the glass. Plus on top we have a product called Spall Shield. It's a hard-coated PET film, which is laminated on the inside of the cabinet, and this prevents actually small glass particles from falling into the cabinet. So now he will start with a hammer, and you will see quickly on the PVB laminate he will make a hole in the glass, and then it's very easy to take whatever out what he wants. This is the piece with the structural interlayer Sentry glass. Much more difficult to make a hole. Plus on the top side you see, because of the Spall Shield, there is not a single piece of glass entering into the cabinet. This is an example of bullet-resistant glazing norm. This is the European norm. So you have classification from 1 to 7, where each classification is associated with a type of rifle. And the testing is done at a certain distance, 5 or 10 meters, depending on the level. 3 shots in a triangle, and it's not allowed. I mean, there is a Spall level where it is allowed some glass particles to fly on the inner part of the glass, or there is no Spall, where actually not a single piece of glass is allowed to be flying off the backside of the panel. This is a product I was explaining you before. It's used in bullet-resistant glazing, so it's a hard-coated PET film, which is laminated on the inside of the glass, and it prevents any small glass particle to fly into the building or into the vehicle. Yeah, so this is just how we see the norms, the European and the American norms, from the low to the medium to the high threat levels. So what we did recently is we did like an alternative test to classify the interlayers. So instead of doing the normal testing according to the norms, we took like a 15 centimeter block of each type of material. We used PVB, we used Centriglass, and we used polycarbonate to see with the same bullet and the same gun how deep the bullet is gonna penetrate into the material. And this way we can quantify and qualify the materials in terms of bullet resistant performance. So you see on the left side, you see our standard PVB where the bullet is penetrating quite deeply. The middle and the right-hand side are two types of structural interlayer. Our Centriglass, where you can see the bullet is actually penetrating only minorly. So this is schematically comparing traditional PVB, 75 millimeters it went in. Our two Centriglass interlayers, 37, 31 millimeter, and then a typical standard product used in bullet-resistant glazing, polycarbonate, which is a very hard plastic material, and is performing very well as well. Comparing BR3, the third level of the European norm, we compare PVB laminate on the right-hand side versus a Centriglass laminate on the left-hand side. And you can see that the total thickness of the glass is much lighter and much lower thickness with the Centriglass application than with the PVB. So if you use a structural interlayer on bullet-resistant glazing, you can reduce the thickness and you can reduce the weight of the total glass. Now a little section on acoustic interlayers. So sound in physics is a mechanical wave that propagates through a transmission medium such as gas, liquid, or solid. And in human psychology, sound is the reception of sound waves and their perception by the brain. So noise is an unwanted sound. I mean, the perception of noise, it differs from person to person. If I play music of a particular type that I like, for me, even if I play it very loud, it's not considered noise. But for my neighbor who wants to sleep and I play my music at 2 o'clock at night, it's considered noise. So it's actually a different perception person to person. There is much more interest in sound reduction these days in architectural glazing because people are living more and more in dense areas. Cities are becoming bigger and bigger. Transportation volumes are increasing. The United Nations, for instance, they predicted by 2050, 68% of the world's population will live in big, dense city areas. So there is a need for reduction of the sound, and there is a need for acoustic performance in glazing as well. If we look at the difference in acoustic properties, 1 decibel difference in a glazing is not practically noticeable. 3 decibel is just perceptible, but 5 decibel is really giving you a difference. And a 10 dB difference is actually doubling or halving the sound as we hear it. So what we can do to reduce the acoustics in a building, we can increase the glass thickness, which will help us reduce the sound entering the building. We can use laminated glass, or we can use as a third and the most performing product, we can use a laminated safety glass with acoustic PVB. We have 2 types of PVB. We have a monolithic acoustic interlayer, and we have a 3-layer acoustic product. The 3-layer acoustic product is mainly used in automotive, and the monolayer acoustic is mainly used in architectural. Here we see the comparison of monolithic glass in different thicknesses compared to structural interlayer, which is not giving a very good sound performance because of a very stiff interlayer. So it gives you a very good structural performance, but in terms of acoustic performance, it's not the best product in the market. So you can see typically between the monolithic glass of a certain thickness and the acoustic laminated glass, there's usually around 5 decibel difference. And it really makes a big difference. So then to finish off with, we have a calculator on our website called SoundLab AI. There you can enter all the details of your glazing composition. You can enter the thickness of the glass, if you use a laminate or not, the cavity of the IG unit, and then on the other side also the thickness of the glass or the thickness of the laminate, and it will give you a prediction of the acoustic performance of the glazing. This is how it looks like, so you just have to enter all the data in the calculator. On the right-hand side, you see what it gives you as a result, and you can download the report from the website. That's the last slide I had, so I thank you for your attention. Thank you.
Thank you. Okay, good afternoon, everyone. Great to be here. Great to be in another event with Zak Façades. I have to thank them for the kind invitation, especially Amr. And my name is Abdullah Faza. I'm the division manager of Fire and Life Safety Middle East. And I have my colleague, James Kelland, who is the technical FLS manager of FLS Middle East. ASG is a multi-disc specialism consultancy firm based in Dubai, Riyadh, London, and Singapore. And we have sustainability, environment, FLS, facade, acoustic, commissioning and testing, data management, MEP, and also cost consulting. So we are going to talk today about facade fire safety. And just to tell you, we're supposed to talk about a few other topics, and we decided to change the topics last night, going from a typical technical way of talking about facade FLS, what are the code requirements, what are the performance-based solutions, and case studies about previous fire accidents, to talk about something else, which is a wider overview of what do we need to do as industry to change the current status of the facade fire safety within the region, and ask ourselves if what we have at the moment is enough or not. So why it's necessary to discuss facade fire safety? As some of you may go like, isn't it a dead topic already? I believe it's not, as the facade evolves a lot when it comes to design, materials, and so on. However, the codes and requirements, to some extent, they're still frozen from 2018, 15, or even if you go to NFA 5000 code, it's frozen from the 1967, especially when we talk about spandrel requirements and so on. So, why it's necessary to talk about facade fire safety? I believe number one is the huge number of involved stakeholders without written document that aligns what is the requirements, what is the responsibility for every single stakeholder, and who is liable in case of anything going wrong. So starting with manufacturers, who are definitely play key role in meeting the classifications of materials, and in most cases, they are not based locally. And then you have the testing laboratories where they are carrying out all the testing as per the listed codes and standards. And then you have the certification bodies who endorse the final result of the testing labs, going to suppliers who are obtaining all the license and permits by authorities who should really guide the market and all the changes when it comes to who is liable, what are the requirements, and how all these stakeholders should sit down together and work as a team. And then designers and contractors, clients, and eventually insurance companies. So all of these stakeholders need to have a clear guidance on what is required, who is liable, and who is responsible. And the question will be, do we really have enough at the moment or not? The second reason is the current complex design of modern facade. And these are some of the projects, some of them are under construction, some of them already under operation, and some of them at very early stage of design. Some of them are using polycarbonate materials as exterior facade materials. And we all know that polycarbonate is very flammable material to be used. However, at the same time, it meets a lot of the sustainability requirements in terms of energy saving and so on. And also, very nice exterior architecture appearance. However, none of the codes talks about how to adopt safe plastic exterior panels materials in our buildings, although the market is going towards this direction, take it or leave it. The third reason is, which is the most important reason, is we have a lot of existing buildings with combustible facades. Some of them may be the buildings that we are living in already, sending our kids to school, enjoy our time in malls, or maybe going for healthcare. All of these options of existing buildings can one day lead to another disaster like the Address fire, Grenfell Tower, Oceana development in Dubai, China Tower, the one you see in the middle, because they are having existing combustible facade materials. And the question will be, do we have any regulations for existing facade and existing combustible facade or combustible exterior wall systems? So to touch base on, I would say, one of the successful models, I will leave it to James Kelland, my colleague, to take you through a regulation case study, what happened in the UK, what has changed, and how did they implement things. Yeah, going to James.
Thank you. Good afternoon all. So today I'm going to be talking about the changes that are taking place in the UK and have been taking place over the past 5 years following the Grenfell fire tragedy. I think it's a really important topic to discuss as there are some valuable lessons to be learned from the UK government's response to the fire. So, understandably, one of the first reactions to the fire was one of shock and confusion as to how something like this was allowed to happen. And obviously there was also a lot of scrutiny over the state of the building regulations. So the government appointed Dame Judith Hackett to undertake a thorough, independent review of the building regulations. So in her report, we can take a look at some of the key findings. So first of all, the roles and responsibilities of those designing, constructing, and maintaining buildings are unclear. Secondly, the regulations and guidance are ambiguous and inconsistent. And lastly, the processes that drive compliance with building safety requirements are weak and there is poor record keeping. So now we're going to look at how some of these findings from this report change the industry for the better. So firstly, there was an update to the fire safety guidance in the UK, namely Approved Document B and the British Standards BS 9991. So Approved Document B was updated in 2019, so relatively quickly after the fire. And the reason for this was primarily to introduce a ban on combustible cladding in all buildings over 18 meters. There were subsequent revisions to the approved document, and one of them was the introduction of sprinklers in residential buildings over 11 meters. Then British Standard BS 9991. So a draft version of this document was issued in 2021. It's now out for consultation, and the final version is expected in the coming months. The changes that we can expect to see in this document are the introduction of staircase pressurization in single staircase buildings, as well as the introduction of evacuation elevators in order to allow all building occupants, including mobility impaired occupants, to evacuate the building safely and independently. The Grenfell fire also had a huge impact on the existing building market. One of the consequences of the fire was that building owners were unable to sell their properties due to the uncertainty of the type of cladding used on the buildings. And mortgage providers essentially were unable to effectively value or assign value to properties, so they stopped lending money. So a couple of documents were born out of this cladding crisis. We have the EWS1 form and the publicly available specification 9980. So the EWS1 form was developed by RICS, the Royal Institute of Chartered Surveyors, jointly with mortgage lenders in order to unblock the market. So the EWS1 form was introduced primarily for building owners to ascertain if their properties had combustible cladding and for lenders to determine how much the combustibility of the cladding would affect the value of the property. So unlike the EWS1 form, the PAS 9980 is a guidance document issued by the UK government in 2022 on how to undertake fire risk appraisals on external walls. The PAS 9980 is designed to give recommendations and guidance on undertaking fire risk appraisal of external wall construction and cladding on existing buildings, specifically existing multi-story residential buildings, and it provides options on how to mitigate and remediate deficiencies in the cladding. Next, I would like to talk about the Building Safety Act, which is a lengthy piece of legislation issued by the UK government, which really aims to put building safety at the forefront of the construction industry. So let's look at some of the key changes brought about by the Building Safety Act. So firstly, residents will have a stronger say in how the building is kept safe. Building owners will not legally be able to charge leaseholders for any costs related to cladding removal or remediation. Accountable persons will need to demonstrate that they have effective measures in place to manage the building safely. And those who do not meet these obligations may face criminal charges. The Act also aims to strengthen the regulations surrounding the testing of construction products. And lastly, the Act will create a clear framework for the design, construction, and management of the homes. So this new framework is also known as the golden thread of information. I mentioned earlier in my presentation that one of the key findings of the Hackett report was that there aren't enough checks on the building safety compliance, and there is poor record keeping. So in her report, she recommends a golden thread of information. So the golden thread is essentially a platform where all the building information is kept in a single place. All the information from the design to the construction, all the way to the occupation of the building. So let's take a look at how the golden thread works. There are 3 gateways to the golden thread. We have pre-planning, pre-construction, and pre-occupation. And after that, we have the occupation phase of the building. The person responsible for implementing and enforcing the golden thread is known as the building safety regulator. And we can think of this person as the local authority having jurisdiction. So in Gateway 1, which occurs before planning permission, or we can call it concept design, the consultant is required to provide a basis of design fire and life safety report. This is issued to the building safety regulator to review and approve. And only once approval is obtained, the project can proceed to the next stage. Gateway 2 occurs prior to construction. So we can say at the end of detailed design phase. So here the client is required to submit detailed building plans and a detailed fire and life safety strategy report to the building safety regulator. And again, without approval from the building safety regulator, the project cannot proceed and cannot move into the construction phase. After construction and prior to handover, we have Gateway 3. It's at this stage where the client has to hand over all the as-built information for the building. On top of this, key stakeholders, meaning clients, designers, and contractors, are required to produce a declaration of conformity with the building regulations. Only once the building regulator is satisfied with the information provided at Gateway 3 can the building be occupied. Now, the golden thread must be maintained over the life cycle of the building, as the building safety regulator will undertake ongoing checks to ensure compliance. One of the key requirements for the golden thread is that this must be kept in like a digital form. Having the information available in a digital format is essential. And it means that the information can be accessed easily, and the information can also be easily updated. So the Building Safety Act does not prescribe a specific platform or software to be used for the golden thread. So for this reason, at ASG, we developed our own smart digital platform called Fire Plus. Fire Plus ensures that all building safety information is placed into a central, secure, web-based data management system so that the responsible person can easily access the relevant data and keep track of all issues related to fire safety. So to conclude this presentation, the key message that we really want to drive home is the importance of having stricter checks on building compliance and building safety, as well as better record keeping. It is the responsibility of the local authorities and our responsibility as consultants to really kind of drive these changes in the industry. So what are the benefits of implementing these changes? So firstly, there's the financial aspect. So property values is less likely to depreciate over time if buildings are designed with safety in mind, and also you'll have lower insurance premiums, for example. But more importantly, the biggest benefit is to the safety of the building occupants. We have an ethical responsibility as fire safety consultants and facade consultants to really kind of design buildings with the safety of the building occupants in mind. Now, facade fire safety is an especially kind of complex discipline which often relies on performance-based solutions. So it's really important that we as consultants, we always strive for improvement and we always aim to keep up to date with the latest industry developments. And for this reason that events like the one today are so critical and are so important. So on that note, I would like to thank you all for listening and I hope you have a good rest of the day.
Thank you. Thank you. Great to see the golden thread spreading its wings into the Middle East, and being a British manufacturer, the golden thread is certainly something at the forefront of the things we're doing as a business at the moment. So good afternoon. Welcome to my presentation on considerations for fire compartmentation within your curtain wall facade design. My name is Ricky Kay. I'm the Business Development and Specifications Manager for Siderise Middle East. Siderise, for those who don't know us, we're British manufacturers and suppliers of passive fire, noise control and thermal solutions for a variety of different facade types. And for 50 years, the business has been supplying innovative and global market leading passive fire, thermal and acoustic solutions into the facade sector. All Siderise systems are manufactured in the UK, and we've got many distribution partners you'll see highlighted on the screen there across the globe who we consider to be an extension to our business. And representing Siderise here in Saudi Arabia are Voco, you'll see their logo up there, also with us on the stand outside. So if you haven't already, then please come and introduce yourselves and come and have a chat to us in the breakout area. And with our extensive library of over 250 system fire tests carried out with a variety of partners to a variety of the global market's most recognised and applicable fire test standards, we at Siderise really do feel that we're one of the global market leaders in passive fire protection. Just to look at the Saudi building code, I mean, the ASTM E2307 fire test standard is adopted by the code here for perimeter fire and smoke compartmentation and curtain walling. And despite this standard's reference within the market's building code, our recent experiences on some project submittals here and some approval processes indicated to me really that there seems to be some uncertainty with the spandrel protection, which is required to pass an ASTM E2307 test, and when it's actually required in a real-life project design. Now, almost all multi-story curtain walling in Saudi Arabia is constructed from aluminium. It is across most of the globe, and non-fire-rated glass. Very rare we see steel facade systems with fire-rated glass, especially above 2 stories. And I'm sure many of you are acutely aware of the properties of aluminium. We all work with it day in, day out in this industry. It performs very poorly when exposed to fire. It will lose structural strength at 350 degrees Celsius. And it will actually liquidize, so vaporize at 660 degrees Celsius. And with a typical office fire burning in temperatures in excess of 1,000 degrees Celsius, and they'll rise to those temperatures very quickly, it won't take too long for your aluminium facade to start destabilizing and falling away and melting if it's not protected adequately. And aluminium facades will buckle and deflect significantly in a fire, even in a temperature-controlled compartment where sprinkler systems may be present. I see in the previous presentation how sprinkler systems have been brought into the revisions to the regulations in the UK. Now, it's unlikely that a building sprinkler system would actually extinguish a developed fire, but a well-maintained and strategically located sprinkler system can be assessed to suppress a fire to the point where the aluminium curtain wall and non-fire-rated glass within the profiles actually remain structurally intact. Some national building codes across the globe, we're in many global markets, and we see that they do call for sprinklers to be located specifically within 600 millimeters of the actual curtain wall facade itself. And they need to be within 600 millimeters if the facade design is to consider omitting the requirement to upgrade the performance and height of the spandrel area which traverses the compartment floors. And within these codes, if the sprinklers are not located within 600 millimeters of the facade, then some of these codes will look then for passive systems to be used to upgrade the performance of the curtain wall spandrel area, as well as increasing the height of the spandrel to prevent what is known in the industry as called the leapfrog effect. Now, failure of a non-fire-rated curtain wall as it traverses a compartment floor will obviously allow fire to spread vertically up the building and very quickly. So our question here really is, should the facade design incorporate a spandrel zone to prevent the leapfrog effect? And if so, should it also be protected to meet the same level of fire resistance as the internal compartment floor and perimeter fire and smoke seal, even in a sprinkler compartment? You know, we construct 2-hour RC floors and then we put a 2-hour perimeter fire and smoke seal in up against a non-fire rated aluminium curtain wall. You know, your weak link is your aluminium curtain wall. So we're really wasting our time and money putting in a 2-hour perimeter fire seal system if we're not ensuring that curtain wall will remain in place for the same level of duration as the perimeter fire and smoke seal in the internal compartment floor. So in our opinion, yes, we should be looking to upgrade that curtain wall. And if so, how should that perimeter fire and smoke seal along with the curtain wall spandrel then be tested for fire resistance as a complete system? And perimeter fire and smoke barriers prevent internal fire spread around the perimeter of the building, so at the floor slab edge. And this leapfrog effect that I'm referring to is breakout of the fire through the facade beneath that horizontal fire stopping, then leapfrogging from floor to floor and bypassing via the outside route. And there is also the need then for protection to the inside of the spandrel to prevent this from happening, so offering some thermal control to the inside of that back pan as well. I mean, if we were to consider a zero spandrel type arrangement, which we all know is architectural preference on the vast majority of high-rise curtain wall buildings, then there is that risk of this leapfrog effect from occurring. And this is because in a zero spandrel design, the non-fire rated glass and aluminium vertical mullions, which span between floors, are exposed all the way up to that single transom, which can cause failure of a curtain wall fire within just 6 minutes of the start of the test. I've seen multiple R&D tests where an aluminium curtain wall that's exposed with non-fire-rated glass will breach within 6 minutes and will actually leapfrog within 9 minutes. Again, we're all wasting our time then putting in a perimeter fire seal for 60 minutes or 2 hours if we're constructing with small spandrels with sprinklers not located in the correct area. And the correct positioning of the window burner in an ASTM E2307 test, which is as per the Saudi building code here, would also cause failure in a continuous glass or zero spandrel arrangement, as the window burner, which should be positioned directly below the single transom, would actually cause those profiles to melt very quickly if they were aluminium and unprotected. So designers in the room and specifiers, sorry, jump forward a slide there. Any designers then in the room and specifiers really should be encouraged to review the fire test reports to ensure that the curtain wall and glazing arrangements which have been tested to either ASTM E2307 or in Europe, the most applicable standard being EN 1364 Part 4, are actually then representative of what your design intent should be on site or is going to be on site. For example, check to see if a steel curtain wall system with fire-rated glass was used to pass the test. If your design intent is with aluminium with the non-fire-rated glass, because if it was, are you comfortable you're going to get that same level of fire resistance performance? And a recent fire which occurred on a medium-rise curtain wall clad building in the UK, it's rare we see fires in curtain walls, so it's rare we get these types of case studies, but it evidenced just how quickly an aluminium curtain wall with non-fire-rated glass can fail in the event of a fire. So the image in the middle, I don't know if you can see, the image right in the middle there shows floor-to-ceiling glazing units in the corner fins, which albeit are outside the line of the internal part of the building. But it really does give a great indication here of what happens then when you've got like a single transom with continuous glass. The upper glazing unit you can see is also shattered, and fire has managed to breach from one floor to the next and shatter that glazing unit. And if that was part of the internal structure, would have then broken into the floor above. However, to the right of the corner fins, you can see the curtain wall arrangement, which is traversing internal compartment floors, have performed pretty well to ensure the fire was compartmentalized to that lower floor. As there was a protected spandrel zone at an increased height, which was part of the curtain wall construction, and by being part of that curtain wall construction, it ensured the flames did not reach and destabilize the upper transom, which then could have allowed fire to spread to that upper floor. So the fire was actually compartmentalized very well there on the inside of the building by introducing that protected spandrel, and the spandrel had to be a certain height to prevent the leapfrog, which is what we saw happening there on the fins. So a certified arrangement to the most applicable and globally recognized curtain wall system fire test standard is demonstrated on the screen here. And with the side-rise system, the perimeter fire and smoke seal is a dry fit, pre-compressed dynamic barrier which is compression fitted to allow for design life movements of the building, because ultimately that joint between floor slab edge and rear spandrel is a movement joint. The whole reason why we leave that gap between the two structures is to allow for various deflections and movements. And by being a dry fit system with no requirement for any sealant or mastic to the top side, gives that installer not only speed of install, significant speed of install, but the flexibility of installing the system from the top or the bottom of the floor slab, so from the soffit, depending on accessibility and also then depending on the location of the connector bracket. With a deep floor slab, it's very easy to have an uninterrupted continuous perimeter fire and smoke seal, which you'd generally look to position below the facade bracket brackets. But if you do have interfaces or the slab bracket or the unitized bracket is top mounted, then we'd look then to pass that underneath. And again, a dry fit solution gives that flexibility. And as described in previous slides, if that spandrel area is unprotected, it will fail very quickly in a fire. And even if the spandrel's backpan is steel rather than aluminium, it's still spanning between floors. So linking your lower transom then to your upper transom. And there's still then a requirement for it to be protected to prevent temperature spread during a fire from floor to floor, which could obviously risk spontaneous combustion occurring to any combustible materials that could make up part of that floor finish, like a carpeted finish continuing all the way into the line end of the upper transom. If you're getting temperature spread by an unprotected spandrel, it's going to cause spontaneous combustion and fire spread that way very quickly. So the side-rise semi-rigid fireboard that you see then to the left of that build-up within the spandrel, it forms itself into curved spandrels as well very easily because it's semi-rigid, and it's recessed between the upper and lower transoms, and it protects the spandrel to work in conjunction then with the perimeter fire and smoke seal to provide up to 120 minutes fire resistance from floor to floor, ensuring that aluminium facade does not fail when exposed to the high temperatures experienced in a fire scenario. And then an additional mullion cover is then required to that exposed mullion as well below the perimeter fire and smoke seal. Now this is very important though to highlight here that not all mineral wool performs the same when exposed to fire in terms of its level of fire resistance and its fire classification. And just because a mineral wool may be the same thickness and density certainly does not mean it will provide equal fire performance when tested. And we've got a great deal of R&D data ourselves that will actually evidence and substantiate this. So again, designers and project superintendent authorities should always ensure that the source of the mineral wool materials being used on a project for fire compartmentation purposes are the exact same as the material source used in the system supporting fire test evidence. So applicable fire test standards for curtain walling. Whilst the applicable curtain wall standard ASTM E2307 is adopted by the Saudi Building Code, there should also be a recognition of EN 1364 Part 4. And this is because both of these fire test standards are as-built arrangements which are tested in combination with a curtain wall assembly. And they both require protection of the spandrel zone to pass the test, as neither of these test standards allow for the inclusion of a sprinkler system. Therefore, protection of the spandrel in both of these tests should be by passive means. And our 10 years of fire testing to the closed furnace fire test standard EN 1364 Part 4, it's evidence to have more vertical and lateral movement in the cavity between floor slab and facade than ASTM E2307 does. Therefore, it puts a lot more onus on the movement capability of the perimeter fire and smoke seal under fire load. So the side-rise dry fit fire and smoke seal is evidence to provide over 120 minutes integrity and insulation resistance. And the recent fire tests have shown up to 67 millimeters of floor slab deflection and a facade deflection of 35 mm as well. Again, no loss of integrity or insulation performance for 120 minutes with no requirement for any sealant, spray, masticing to the top side. So as per the Saudi Building Code, this is an extract from the ASTM E2307 standard, which shows an open furnace test arrangement, so slightly different to EM, which is closed furnace, whereby you have a room burner positioned inside the lower compartment and a window burner then positioned outside the curtain wall, which is replicating fire breaking out via the non-fire rated glass and curtain wall profiles that span between the floors, travelling up the outside of the spandrel and then perhaps breaking back in above. For any designers, engineers and consultants in the room, as stated earlier, it really is best practice to request copies of actual fire test reports from the manufacturers or system test owners to satisfy yourselves that design intent on your project is representative of the fire tested arrangement, rather than just relying on third-party certification documents, which can end up throwing up multiple listings based on just one or two tested arrangements. And what this image on the screen is showing here is actually a steel profiled curtain wall system. So a fire rated curtain wall, which is referenced in its third-party certification document, which supports this fire test, as having a 400 millimeter high spandrel, certified to ASTM E2307 for up to 120 minutes fire resistance. However, what's actually been done here is a lower steel dummy transom has been introduced with fire-rated glass above. And the window burner, which should actually be positioned below the transom that's supporting the 400 high spandrel, has been moved below this dummy transom, so really creating a spandrel height that's actually more than 400 mm. So again, consultants and regulating authorities should really be then checking to see within fire test reports, that's just jumped on a little bit, apologies. Within fire test reports, again, to satisfy yourselves that the design intent is representative of what has been fire tested. What's now being shown on the screen here is a successful ASTM E2307 test conducted with siderized perimeter fire and smoke seal, our dry fit solution, with the siderized FB then to within the spandrel. And if you look at the middle image there, as you can see, the lower transom being aluminium in the test, which is as per real life scenarios has melted, as have the vertical mullions, but the upper transom has remained structurally intact, ensuring the full system keeps its integrity for the required level of performance of the perimeter seals. Last couple of slides, conscious of time. But when we consider the perimeter joint to an aluminium curtain wall is a dynamic seal, which is there to accommodate design life movements of the building, it's critical then that that perimeter fire and smoke seal is evidence to accommodate the building movements for the same life expectancy of that building. And by going through cyclic movement in accordance with EAD standard, prior to furnace burn, Siderar is in a position to offer up to 60-year design life on a fire performance of our dry fit solution. And we at Siderar always take a system approach to fire testing. So again, following the theme of the golden thread, we test with the global market's leading system manufacturers, many of them we've tested with. And robust third-party certification or certified system testing really does support our specification drive as a business. And there's a lot of fire test evidence that we've got to support that. So our technical and site services team are here to assist from project detailing through then to local code compliance and sign-off. On-site mock-up then follows next, with the ultimate end goal then being a robust, fire-safe building envelope to the building. I will very quickly scroll through verification. Our on-site installation training scheme is third-party accredited to ISO 29993. Very rigorous training scheme that we have to, the installers and applicators have to go through before we can issue then a certificate to say that installer is competent in their field. And for quality checking throughout the installation program, we have the Siderar Inspector app, downloadable, a complimentary level of service on iOS or Android, where it gives you and your client and the consultant or any QA manager on the job the flexibility of monitoring the quality of installation throughout the install program. Because what we're trying to avoid is this. Terrible installations which can be covered up very quickly with GI sheets and all sorts of other bits and pieces. And if we're not monitoring the quality as we progress, we're really all are wasting our time with quality engineering and testing and certification. Final slide. What's next? Robust system testing and third-party certifications to the most applicable standards for curtain wall assemblies is key to ensure system performance. And in our opinion, continued reliance on sprinkler systems being used to omit the requirement for the spandrel protection that's present within ASTM E2307 testing, in our opinion, should really be revisited. Or at least the sprinklers required locations within a building should be more specific within the code moving forward when allowing the emission of passive fire protection to the spandrel. Thank you for listening. Sorry it was a bit rushed towards the end. Thank you.
Okay, thank you. Hi, everyone. Good afternoon. It's great to be here today. Really listening to all the speakers, very interesting topics. Let me introduce myself. My name is Zaid Suleiman. I'm the facade segment manager responsible for the business development of healthy facade within Middle East, Turkey, and Africa. And here I'm introducing my colleague Ahmad, who unfortunately won't be able to speak. He lost his voice cheering up for Morocco in the Qatari stadium. So, he won't be able to. So he's the business development manager for ventilated facade. So let me start. On a quick note introduction on Hilti. So Hilti, founded in 1941 in Liechtenstein. It's a principality that's between Switzerland and Austria. It's well known as a world leader in providing design and manufacturing cutting-edge technologies and services and softwares. And also, in Hilti, we're highly diversified and segmented, aligning with the market. So we have steel and metal segments, we have interior finishing segments, we have MEP segment, and obviously facade segment. And we here represent the facade segment. In the facade segment, we provide fastening solution, fire stop solution, and on top of that, engineering and project management service and solution to our stakeholders that are the facade consultants, contractors, and mainly in focus on 4 domains, which is the curtain wall, cladding envelopes, window walls, and structural glazing. So since we're in Saudi, it's important that we speak about the 2030 vision. As we all know here, as per the United Nations, Saudi is focusing on achieving the 17 sustainable goals. And in particularly, I would like to focus on 2 main goals, which is number 7 and 11, when we speak about affordable and clean energy, and also sustainable cities and communities. And as per the report, 29% of the primary energy and the electricity produced, that is 75% of it is used by building. And that's why, as per the report, it's important that we provide well thermal efficient buildings that help in providing energy savings. As per the report, if we have a well insulated buildings, we can save up to, we can have a reduction up to 30%. And that's why there's a high priority in building efficient envelopes that also, at the same time, we need to look in how we can manage those fire risks, as a lot of speakers that they spoke about in such envelopes. That takes me to today's topic, which is mainly focused on 2 points, which is how we can obtain sustainability and energy efficiency, and also at the same time managing the fire hazards that would be coming out of it, and in both curtain wall and cladding envelopes. So I'll start and go with the cladding envelopes. All right, so in cladding envelopes, it's important that when we speak about energy efficiency, we focus on 4 fundamentals as per the research and the standards. First of all, we need to have vapor barriers that manage the condensation, also to have efficient windows and doors, door seals for the air infiltration, and of course, to have exterior insulation systems that improve the thermal efficiency, the thermal insulation of the buildings. And the last part, which is quite critical, is the effective ventilation in the cladding, which commonly is missed out, and is commonly known by having a 1-inch cavity or airspace that is between the back of the panel and the insulation that allow the air to flow as a system, which would improve the thermal insulation of the building, improves and provides, it acts as a equalizer for, as a pressure equalizers, and improve the durability. However, by following those methods and ventilation, there are some risks that come from having ventilation behind the cladding, which is the fire risk, as we can see here, where it acts as a chimney effect. So if we have the fire falls between the back of the cladding and also the insulation, due to the heat conduction, it goes up into vertex. And that's why it's very important that we deal with such matter by having cavity barriers. We'll have cavity barriers, that is as we spoke here, the approval document B. And for example, here we have the UAE Civil Defense, where it recommends to have horizontal cavity barriers at every floor levels, and then to have vertical barriers at the corners and also around the windows. So considering those designs aspects, which are quite clear, despite of that, we still realize that there are issues when we go to the sites. So first of all, we have, despite of those designs, there's incompliances which comes to the insulation, where we realize that they're wet and damp, and this results in losing the thermal efficiency performance that we're trying to seek due to the lack of the ventilation behind the system. Another aspect is the buckling of the panels and the falling of the panels, and that's due to the lack of the pressure equalization and lack of ventilation behind the claddings and lack of alignment. Another point which a lot of the speakers mentioned is the uncontrolled fires, and that could be because of lack of cavity barriers or using inappropriate cavity barriers. On top of that, another thing is damage and cracked panels is the reason behind of using mix and match frames or steel frames that could expand and are not suitable for such type of cladding. So the question that we ask ourselves, so what are the reasons behind that, despite the design factors and our consultants are aware of it, is the lack of having a full system supplier. So everybody say, hey, we need to have panel suppliers, but that's also as important as to have a full system owner for the substrates, because it's the backbone of the system, and you need somebody who owns the complete package and the ownership, not only in terms of profile, but in hardwares, softwares, and services. And what exactly the ownership that we're speaking about is the ownership in both phases, the phase of design stage and execution stage. So at design stage with our consultants and architects is to provide them, in lieu with the insulation and the panel suppliers, to provide them the full structure and thermal calculations of the entire envelope, providing not only typical drawings, but rather special drawings, specific drawings for the doors, to the window opening, to the joints with different material that make sure that it's catered for the project. And then once we provide those systems, those offers, we continue in the execution level with the contractor as a full owner, where we make sure that they have the right planning at every elevation, and at the same time to provide them the full hardware and software tools to make sure that, for example, transferring the points, which is a very critical matter, how to transfer the points into the actual and use the right fasteners and different substrates that you have, and also, of course, to have the right profiles, vertical profiles and horizontal profiles. So in Hilti, this is what we're happy to offer and glad to offer, is to provide a full system solution that is not only in the profiles and the brackets and the fire barriers that we offer, but also to own the entire package, including serve in terms of engineering and software and training on site, which will improve and make sure that we comply to such design criteria and eventually succeed in getting really efficient buildings and getting those benefits. And on top of that, we have also some cutting edge technology when it comes to bracket fixings, which are the polyamide brackets, which it has a better thermal efficiency by almost 60% compared to standard brackets that are there out in the market. And of course, those systems it's compatible with all different types of claddings, so it's not restricted to any type. So we can go with fiber cement, ceramic, stone, composite, metal, and so on and so forth. So due to that, we've been fortunate enough being known as a trusted partner all around the globe. We have been lucky to work in several projects, and one of the recent is the Riyadh project in Saudi. Now, this takes me quickly to the second topic, which also was touched base by other speakers, which is the pacifier compartmentation in curtain wall. So when we speak about curtain wall, when you speak, we have to emphasize on, as other speakers also, is the internal joint, the perimeter joint, which is usually between the slab and the curtain wall. It could be going, as a standard, it could be 30 mm up to 300 mm, and some projects it goes to 500 or even a meter, where me and Ahmad actually can live in that joint. So it's important to treat that joint, but before speaking about the treatment, there are two dimensions that I would like to highlight. First of all is the behavior of fire. There are two behaviors of fire which we spoke about throughout the day, which is first of all the chimney effect, where the fire just tends to go upward due to the difference of air in terms of moisture, thermal, and temperature. So that's one trend of behavior. The second behavior is the leapfrog, which is the fires trying to go around the perimeter joint, and that's as the fire is building up in the origin, the heat builds up, the windows and the glass shatters, and then it vents outside the flames to the outside and heats the exterior of the building. And eventually, as time passes, the exterior building also heats up and shatters, and then the flames goes to the second floor. And as a note, such concern in leapfrog is usually addressed by having three ways. First of all, to have a minimum vertical distance between the separations or the openings, which is known as a spandrel height. Second is to the presence of a horizontal balcony. Third is to have a full sprinkle system within the building. Now, considering the first behavior, which is first dimension was the fire, the second dimension is the dynamic. And I emphasize on the dynamic is because curtain wall is subjected to many loads, and eventually the edge of the slab is subjected to many movements and combined movements. The first movement is the seismic displacement in junction with the seismic zone. The second movement could be the facade thermal movement of the aluminum frame of the curtain wall, and in addition to that, the movement due to the structural deflection of the slab, where the bracket fixing of the curtain wall is fixed, and that's due to the live load, which is the wind load, and also the dead load of the building as the slab sags as the years passes by. So taking in consideration those two dimensions, it's very important that we design and make sure that the parameter joint acts as an extension, a 2-hour fire rated to the floor floor slab. So it should be an extension to the floor slab, achieving the 2-hour fire rating required. At the same time, managing and accommodating the dynamic movement of the joint. And when we speak about the dynamic movement, so what if the system is not built up to accommodate for movement? What will happen? The first couple of years, wonderful, amazing, it's fit in, it looks beautiful, but 2-3 years down the line, as the facade moves and as it does not accommodate, it will fail in preventing fire and smoke. And here's as I'm just showing, here's just a slight example as a movement happens and the joint does not really accommodate for such movement. Eventually the smoke will be passing by. So if the system prevents fire, but then it's not preventing the smoke, and as we know, the smoke is actually the #1 risk when it comes to fire, not because of only inhaling the smoke, but also it blocks the escape routes that are designed as per the FLS. And that's why it's very important to use a full tested system, with healthy wet system that consists of applying an acrylic water-based intumescent sealant on a compressed stone wool insulation safing in the joint, supported with a high-density vertical stone wool insulation on the spandrel areas. And we can see our CFSW that, if you where it accommodates those movements and make sure that the smoke is 25% movement. And as also my previous speakers highlighted, is how we can guarantee that the system is performing. One of the best standards that we also recommend is the ASTM 2307. The reason behind that, because it mimics the actual scenario. So it consists of full configuration, 5.3 meter height, with a window opening in the middle, and burners in the internal and the external, which also mimics the leapfrog and the chimney effect. And on top of that, the system here also takes into consideration not only the F and T rating, but also the movement. So it takes the cyclic movement into consideration, which is both horizontal and vertical. On top of that, also the smoke development, which is the air infiltration leakage through the specimen as per UL 207. And in addition to that, that's important, is the water resistance. So the W rating of the system, and yeah. So here is our healthy system for perimeter fire joint, which is tested as per ASTM 230, and it has been tested in considering all of those factors, which is F rating, T rating, movement, and W rating. And finally, I would like to close my presentation by highlighting that those fundamentals that we highlight in terms of building energy efficient envelopes, managing fire hazard with passive fire compartmentation is something that we're committed in the market, and we're driving in not only in such conferences and to the great audience that we have, but actually we've been very active in the market by making sure that we have memorandums and cooperation with various entities and authorities For example, here we had a memorandum with the Saudi Council of Engineers to train them on the fire prevention and building the code standards in the market, and also some of the universities where we accommodate and train their students at an early stage to seed those fundamentals in the new generation and make sure that we achieve the 2030 vision. So I'd like to thank you so much for listening to me, and I'd like to invite you to our booth in the coming break so we can deep dive in some of those discussions. Thank you.
Designers, consultants, contractors, fabricators, and it's been a very learning session for us. I thank Zak team for organizing this great event over here, and we always look forward to participate in Zak events globally. So yes, a bit about myself. I am Vinay Sharma. I am working in Jotun powder coatings since the last 15 years closely. And I've got a coating experience of about more than 25 years. So I would just go around and talk something about powder coatings, something about Jotun, something about new technologies which we've got, metallic products, and some references. So this is our factory in Norway. We are a Norwegian-based company. This was established in the year 1926 with a small boat solution for a coating solution for marine. So currently, from that in 1926, where we are now, we are in close to 100 countries, 38 factories, and more than 10,000 employees on a global level. We are present in decorative paints, marine coatings, protective coatings, and powder coatings, which I represent. If you see this, we've got a single source solution. We have got coatings right from the foundation till the after the building is constructed. So we've got coatings for rebar, we've got coatings for pipelines, we've got coatings for steel protection, we've got coatings for fire protection, we've got decorative paints, we've got architectural powder finishes, and we've got floor coatings as well. So we are a fairly big organization on a global level. We are a USD 300 million company, and we rank among the top 5 companies on a global level. We've got a worldwide presence. We are present fairly in by large in most of the regions present across the globe. MIA, that is Middle East, India, and Africa. We are also present in SIAP, and we are continuously protecting assets. So globally, there are about trillions of dollars which are wasted on corrosion. So corrosion, why it is important, we have been giving solutions as Jotun to onshore and offshore structures globally. So this has been going on for centuries together, for 1 century together. And then of late, people have been diversifying into powder coatings from liquid coatings. This is only because of low VOC or zero VOC content in powder coatings. So what is VOC? VOC is basically the measure of a solvent in a coating. In powder coatings, there is zero solvent. And these kind of VOCs, they affect our body. They get into through our lungs and they affect our health. So Jotun is very much focused upon green steps. We focus on reducing VOC emissions, reducing carbon footprints, reducing energy consumptions, reducing hazardous wastes, reducing waste on a broader scale. When it comes to LEED, when you use powder coating, you get 2 credit points for the material which is used. If you're using a TGIC-free powder, you get 2 points. If you are using heat island reduction, like cool shades, you get additional 2 points. For if you use paints, Jotun paints all together with Jotun powder solution, you can get up to 11 LEED points. Some references which we have done globally, this I cover the region. Dubai Expo, we have done 20 halls for LEED, out of which KSA was one and Dubai was one. So we have extensively applied these kind of solutions, both paints and powder for Dubai Expo. Coast University, Masdar University in Abu Dhabi. These are 3 examples for LEED which I can give. Not mentioning that many more projects on LEEDs are coming within Saudi Arabia. So, powder coatings. So, what are the powder coating advantages? First is durability. Second is appearance. Third is sustainability. So we, as a forum over here, we look forward for green buildings, and sustainability is the key buzzword which happens. So we have got all 3 features in our products in powder coatings. So why powder coatings? Because low or zero VOCs, they are recyclable, and they are applied in single coat, unlikely with liquid coatings where you need multiple coats. So the trend is changing. Many people are now converting from liquid solutions to PVDF, liquid solutions to powder coatings. So in a way, what I would compare is powder versus PVDF. Powder has got no VOC. It has got a variety of colors. It has got a very good mechanical resistance. And we've got a number of approved applicators to apply Durasol. What happened is we tried and tested some of the PVDS. We took some samples. We are very curious about PVDS in the market. We took some samples from the market and we applied some coating solutions ourselves. So it was looking very good at the start of the application. It was excellent finish. However, when we tested for weathering, it failed after 200 hours. Some examples of Durasol which we applied in Aramco, in Dharan, King Salman Park, Delta mixed use, that was in Marriott Hotel, Jewel of the Creek in Dubai, Al Badia Terraces in Dubai, Four Seasons Hotel, World Defense Show in Riyadh. So these are some of the examples of our coatings which have been applied as an alternate to liquid coatings. So powder versus anodizing. Anodizing, if you are using a powder coating, instead of anodizing, you save 40% of water, 10% less electricity, and 20% less gas. So if people are aware with anodizing, it's a process to the aluminum substrates where the anodized layer becomes a part of the aluminum. Whereas the powder, it becomes a coating on the aluminum substrate, but you save on water, you save on electricity, you save on gas. So we've got Aurora collections, which is near to anodized range of products, and we offer this in 11 colors. 11 colors, all these colors are anodized colors, which are very close to the anodized anodizing available in the market. Some examples which we've done Aurora collection and Marriott Hotel Riyadh. So Jotun products and collections. We've got mainly 3 products for architectural. we've got Durasol, we've got Super Durable, and we've got Jotun Facade. We offer 30 years of warranty in Durasol, 30 years of warranty. We offer 25 years of warranty in when you use Super Durable. These conform to ARMA, American Standards, ARMA 2605, and American Standards ARMA 2604, and are available in many colors, and they are also available in many collections. Cool Shades and Aurora for Super Durable, and Timeless collections for Durasol. With the change in trend, we have seen that many facades are now being developed with steel. So when they are developed with steel, there is an urge to have primers for steel because they will corrode. So we've got a range of primers which are basically standard and premium. We recommend Primex Protect, Primex Extend, and top coated with Super Durable and with Facade. For when you go about with this combination, we offer you warranties of 5 years to 10 years. So warranties were not, earlier they were not available with us, but now we have worked on it and we are offering warranties for it. Collections, we have got a few collections with us. This is Woodspiration. First is Woodspiration. If somebody wants a wood finish on aluminium, you can get a wood finish. We've got a booth outside. You can have a look at our wood finish exhibits. We've got Cool Shades. If you want to save electricity and have a temperature gradient down in your room, you can apply Cool Shades. We've got Aurora, which is near to anodized collection. We've got Sahara if you want natural finishes. Then this is a new range of product, which is Super Durable 2900 series. They provide an ultimate matte effect. Again, this sample is available on our booth. If somebody wants to have a close look at it, you're most welcome. So it will provide you a good lifetime expectancy. Again, we offer you 25 years warranty on this. Metallic products, you've seen metallics. All of you drive cars. All of you drive cars. Car have got metallic effect, so it shines. It's got luster in it, so it shines. So there are basically two kinds of metallics in powder coatings, which is dry blend and which is bonding. Dry blend is a loosely flaked aluminum pigment addition to the powder, whereas in bonded you get fusion bonded by heat. So in it you get a cohesive film, and you get consistency in color. It's totally recyclable. You get a uniform, smooth appearance. Whereas in dry blended, you don't get all this. In dry blended, you get color differences when you are using recyclable powder. Examples of dry blend, if you use this kind of dry blend, that is if you use a dry blend virgin powder, this is the finish. But when you are adding recycled powder to it, the finish changes to this. So whereas in case of bonded, it is fairly the same. The rejections are very less. So you get a color consistency in case of bonded. Examples, we've done Z towers in Egypt. So now it would be interesting to see Jotun powder coatings perform over a period of time, because I'm speaking. I'm talking about warranties. There should be some track records where we have measured at the time of application and at the time of X years, after X years. So we see some prestigious projects. This is the Palm Shoreline apartment. You see this panel on the left, it's a master panel which we did in 2003. And we tested this after 13 years. And this was what it was looking like. It was absolutely the same. It was no difference at all. Then we did a test for the Palm Hotel. This is, when you enter the Palm Hotel, this is the type of colors on the aluminum facade. So either door profile, it was painted in 2003. And we tested it after 11 years, same. It is no difference. And you see, it is standing in between a sea atmosphere. The environment is very harsh. So it is performing there. So definitely there is a reason to believe that it will perform. Burj Al Arab Jumeirah, similar story, 19 years of track record. So you can see before and now. So, and many of the structures which we are doing, which we have done right now and which we are already doing, which goes on. Roshan, you've heard of Roshan. So we are also present in Roshan. We have supplied super durable coatings in Roshan. We have supplied super durable coatings in Suleiman Al Habib. These are the recent ones. Khalifa International Stadium, Doha. People are, I'm sure you watch football. So the World Cup is happening in this stadium. Powder coatings is used from Jotun. New port project, it's in Doha, Qatar. Oryx, Rotana, Masdar, Wasl Tower, Leighton District, Masar Villas, Shobhas Tower. So just to conclude my presentation, I would like to mention 3 things. Jotun has got a global presence with a diversified experience in single source solution. Second, powder is growing at a rapid pace and replacing liquids in most of the places. Third, we offer extensive solutions in high durable finishes. So that's it what I want to speak about. I hope things were okay. And thanks for listening to me.
The moderator for the next panel discussion, which is Hassan Wakat. I would like to invite also Ahmed Badran. I would like to invite Osama.
It's a pleasure now that to make a comment of what we have got and what we have seen. There is a lot of creativity, innovation, a lot of great ideas for modernity. Our problem is, or our dilemma, how to authenticate this. Because we've seen that there is regulation coming down saying, King Salman, mithaquna. And we have noticed that in the municipalities, they put rules and they're always asking, how come? We need our identity. We want to feel that there is continuity from past to future. Our dilemma is basically how to give answer to these things. There is a great attempt we have seen here that we can maybe highlight that it's not just saying that there is eclecticism, there is tradition that we have to be inspired from, but how can we make a sense of belonging? This is the question. Sense of belonging, it is an experience to human. So I welcome our colleagues because they have experience and we can chat all together. I'm not a moderator more than just trying to highlight points and maybe I can share them with their ideas. Dr. Ahmed Badran can share me in the points that we want to highlight and we want to inspire you that there is possibilities to authenticate modernity and at the end to have it as a sense of belonging. Thank you. So the first question, if you please,
okay,
Dr. Afaf.
First, let me just have a brief commentary. And thank you all for the presentations you gave. They were wonderful. And we know that glass is here to stay because it has many specifications that are very much needed. And I'm very happy that most of the presentations gave the use of glass, which we all cherish, and at the same time gave solutions for any problems that come up with it. So one of the challenges that we raised in our discussion was designing new buildings in historic urban contexts. And this is sometimes a challenge because most of the people say, well, glass is a modern material, whereas glass started like, you can say the manufacture of glass may have started 5,000 years ago, but actually in the 6th century, it started to become sheets. And then it grew to bigger sheets later on in the 18th and 19th century. So from there, I'd like to open the floor also for colleague panelists, if they would like to touch on building new buildings in historic context.
Dr. Abdullah, you'd like to start? Okay, first of all, thank you very much for this great introduction. And it's very interesting how to express ourselves as, I would say, architects, and at the same time, urban designer, regulators sometimes, authority having jurisdiction, and authority setting rules in general in the region. How to tie the facade design in general to the local environment and the royal and the local context. A question could be asked: if we design a building in, let's say, London, UK, and with the same requirements, with the same client, he wanted to design the same building in Riyadh, from the same architect, those two buildings would be the same? I think the answer should be no. Because there is a major factor and a major aspect we should consider. Maybe not one, maybe few. One of them is the climate. Climate in London is totally different than climate in Riyadh. Second thing is the vernacular architecture in Riyadh is different than London. Regulation, building regulation in Riyadh is different than London. So the simple answer of my first question is no, we should not design the same building, same requirements in London as Riyadh. Glass, as Dr. Afaf mentioned right now, is a modern material, and it's actually invented 5,000 years ago and 100 years ago. But at the same time, architect could use it as a tool to express and to respect the local regulation, local climate. This is why, for instance, when we saw the presentation of the presented architectural, this is why we have kind of respect to the climate when we introduce shading device, for instance, in front of the glass. This is a kind of a tool architects could use to express how the building should be designed in a harsh climate, like Riyadh, for instance. I could give so many examples of that, but the conclusion from our perspective that the vernacular architecture in a building designed in the Middle East in general, in Riyadh, in the Gulf, should respect the culture, should respect the heritage, should respect the traditional of the people who's working there. What do you think, Dr. Abdullah?
First, I would thank for the invitation and the great events. And I would say Assalamu alaikum to everyone. Second, I thank my colleagues and give me this opportunity to talk and speak about my country, my city where I live. I'm working in King Abdullah Financial Districts, which is one of the iconic and prestigious and important project in Riyadh. King Abdullah Financial Districts, it's in a concept to show the strongest of the kingdom, the strong economy, and how is Riyadh now become one of the main cities in the world. So the elements being used there, it's a high-rise building. It's a combined between glass, aluminum, architects using with international architects' office names, and become like a signature in Riyadh. Yes, we need this kind of variety. We need this kind of a project to be in Riyadh. But again, let's say the touch and the unique in Riyadh of the elements, of the architectural element, still can be applied by using sample. I saw previously in one of the presentation where it showed one of my colleagues, Riyadh Avenue projects, and there was slightly change from the original design by using colors and element just to use what we call it Suleimani style in architect, just to give identity to our building. I believe understanding of the society, people, environment can be end up with a very good product, can be end up with a project where everyone can be used, can be given a good impression for the city, for the users from all elements. It's an experience, I have it myself among the construction of this project. Now it's become to life. We can see people how they enjoy living in this project. We can see how this project can be also showing in the country itself, showing in any brochure, or become an element for Riyadh. So yes, glass, aluminum, high-tech, new technology, important, and it's required to be part of the cities.
Thank you very much.
Yes. The most critical matters that, okay, I can highlight identity within Riyadh anywhere, but if it is belonging to a historic existing building and we have to deal with, is the problem. So we've seen beautiful examples here, trying to give an answer for that. I give you an example. The project, like the line, for instance, if they want to over-respect nature, so they're gonna be a mirroring nature. If there is a historic building and we don't want to create an exotic element or maybe create something that will look overwhelming on. So we go another matter, that what happened in, the beautiful museum for Dara in Murabba, we have got example that we shared in this project, that either we mirror it or we create a neutral facade that not to compete but to complement, which is happening like the Islamic Museum. If you go and visit Al-Murabba Museum, it was a very genuine solution. And even we've done something furthermore, that in the historical buildings, bridges was there, but some of them collapsed. So some of the guys, they advise us, don't worry, link it, have it with steel and glass, and it will not look exotic. And that was a surprise for us, that when this has been achieved, it wasn't at all harmed the overall, because it was the house of King Abdulaziz in the history. So I mean, there is many ideas that we can do. Furthermore, if we can't compete at all by mirroring or by maybe trying to have a structure, and we need a building, if you make a mimicry of nature or maybe a landscape within, so the building can give a sense as if it is part of the landscape, it can merge as well. So there is a lot of ideas when we have a very sensitive location with a very important historic element. Thank you.
Thank you very much.
So maybe I'll go furthermore. Creating a sense of belonging. I think this is the right word to say. What is sense of belonging? When I go to a certain environment and suddenly I get familiar with all what I need, I feel relaxed and content with that, it will give me a good experience. Over time, it will be part of my good memories. And I will adapt to that, and then I will say, I belong to this. It could be part of the identity afterwards. So I mean, a sense of belonging is an issue. I want you to highlight how can we generate a sense of belonging in the urban or built environment? Would like to answer or give ideas and thoughts? Go ahead. It is like alternative words of saying identity or saying that's my tradition or that's my whatever, classicism. So sense of belonging, it's a matter that will be later on my identity. I want you to give a thought about that. What do you think?
If you allowed me to
Yes.
interfere in this point. So I usually saying the fashion is very close to the architect. So if you're looking to us, without saying I'm from Saudi Arabia, you can know from my clothes immediately that I'm from Saudi Arabia. And if there is another fashion clothes for different country, from Japan, from UK, we can immediately buy the fashion, the original fashion of the country, saying this guy from this area. So the building itself, it can also giving the identity of the city itself. So I will have a very good example of the Zoha Hadith train station in Kaft, it shows exactly the nature of the sand in Riyadh. So if you drive outside of Riyadh, you can see the nature of the sand. And by this iconic train station, immediately you can link between the concept of the designer and the nature of the land. So this is, we can say, belong to Riyadh. It's very high-tech project. It's not easy, even from Façade, because I've been participate in some of the ongoing project for this with the Permistaliza, the contractor, and I know the difficulties they face to implement this idea. However, the end product, it can say it's belong to Riyadh, and I believe this is the message and to be delivered by the designer and the manufacturer to the city.
Thank you.
Please.
Yeah, if you allow me, we as people are not only who we were in the past, but we are in constant change. And I think honoring this change, whether it is in costume or in architecture, is just reasonable and expected, and is part of development and progress. And a sense of belonging is created once we contribute to the manufacture of building materials. I think, and from this panel, I call on all the Middle Eastern countries to start manufacturing new materials and developing present materials. And from there, you can create a sense of belonging, not only to culture or feature or aesthetics, but even to the use of materials that you have. Thank you.
I would add just something very trivial here. I think Riyadh city, especially the Royal Commissioning of Riyadh city, set a kind of regulation, if you will, about how the design of buildings, especially prime buildings, major buildings like high-rise and airports and those mega projects. This is why I think they put a kind of regulations, and they recommend the architects and the designer to use something called Salman architecture. I think SOM architect, our colleague here, represented something related to that issue. They set 9 rules about how you design a prime buildings in Riyadh, especially in high-profile areas like King Fahd Road, Olaya Road, and all those major roads, and make it belongs to Riyadh through Salman architectural regulations. Either, as you mentioned, Doctor, using material, color, design itself, and when you look at it on the first sight, you feel like this building belongs to Riyadh, or this building belongs to different place, somewhere else. We shouldn't limit ourselves in using only building material or colors or a triangular element to represent the traditional buildings in Riyadh, for instance, as we could see it in Dir'iyah or in Dira. If you appreciate the design of the building and you feel like this building belongs to Riyadh, this is good enough. We should not overdoing it, because if you start overdoing the design, you will end up of having rubber stamp buildings. All buildings using brown color to imitate the sand or to imitate the mud they are using in ancient buildings in Dir'iyah, or using elements of triangular or horizontal wooden beams. The architects, the limitation of design through architects should be endless. Sky is the limit, as they are saying. So we should always, as Dr. Afaf mentioned, that you have to create, you have to invent, not having similar buildings along the prime locations. So when you appreciate something, you put the criteria, then design it, take it from there, consider the climate. Climate we shouldn't ignore, as in harsh climate in Riyadh, we should not ignore. It's hot, dusty during summertime, and it's cold during winter time. So we should respect the environment. We should respect the culture and come up with the new ideas all the time.
Okay. So I'll go further to that, Can we create social and healthy environments? We should not forget that we have, as they mentioned here, human-centered. I mean, when we consider people and let them associate with the environment and they feel happy, they have got their needs, and they have a beautiful experience. The question is, social environment is really was a big dilemma here because of the urban context, and they followed the Xiadis design planning and so on. We got a lot of problems. So I'd like to highlight how to create social and healthy environments for people so it will be livable and people will get happy with, and accordingly it could be part of their identity afterwards. So the floor is open.
Want to say something, Sir Abdullah?
If I will, I found this is very important point, to honest. And from my personal experience, I start my life with the 3 children where we live in apartment. Then I face a problem with my children every time they get sick. And with any small change, I should take them with a high temperature and cough. And then my father gave me advice. I found it very useful. Then he told me, take them outside. Take them to the external. Let them exposed to the sand, to the weather. I think they get sick because they stay all the day as a children in the apartment closed. I spend too much time in the work, my wife. Then I start thinking, I believe this is exactly the problem. We start to think too much about creating a comfortable zone where we start to live, I would call it in a boxes. We're not exposed to the environment, and I don't find this one healthy. Second thing, the social, by the design itself, by creating space. Now, unfortunately, with this, they call it social media, but it's not social among the family itself. So we've been noticed now people start sitting alone with these devices, spend too much time, and there is no space where it's gathering of the family or space for the employees or public areas. Especially, I would talk about Riyadh. We face problem in the beginning of let's say, new buildings, new space, everything air conditions. Then people discover there is no area to sit, no area to speak. Then they start to change this thing by create more social, more open space for the employee, chat, zones. So this is where we consider, I would call it very important to have social design, healthy for the people, and the other thing, the material that we use. I'm not expert, to be honest, in the material, but I keep hearing in the news or media saying this material discovered it caused the cancer. This material is very dangerous. So from the producer or from the company, I would highly recommend and appreciate if they spend more time to be sure about the material they or the product they sell to the market. It is friendly, healthy to the human. In the end, we need to have environment safe and people live more, longer, healthy.
Okay.
Thank you.
Can I just add a very quick one before we depart from this? It's always important to learn from the past when it comes to how to live healthier and happier. I guess when you look at how those buildings designed in the past, especially in a hot climate, you will find a very important element, which is the courtyard. They always having a courtyard, either in Riyadh or in the north of the Sham area. They are using this important element to gather the family during the day, taking dinner at night. Most of the activities and most important activities would take place in this area, in the courtyard. Courtyard, it's not only having a social importance, it's important as a climate element, if you will. So if we start from the small cell, which is the house or home. Before you mentioned, Doctor, the design, the urban design of Riyadh before it's been made by a foreign people, like they don't belong to our culture. The design of Riyadh, the building or the villas, we're having the building in the middle, sit back from four sides, a lot of wasted space, especially toward the street. But when they thought about it just recently, they realized that this is not the right way to design villas. This is not the right way to design buildings. Let's change. Let's create some kind of more space to the family so they can enjoy their time either during the day. Nothing wrong of enjoying the time even during a hot days if you provide the shade, if you provide the right elements like water feature, a lot of trees. So they changed the regulation, the building regulation recently to have the villa itself build the building itself on the two sides of the land, allowing more space toward the other two sides and adding flexibility so the building could be L-shaped, could be U-shaped to create a more space to the family. Taking this and multiply it by 2-3 times the neighborhood, the designing of the neighborhood itself. Now we are seeing different design coming up. We are seeing parks, central parks in the neighborhood. If you go even outside the neighborhood, you could see a bigger park now being created in Riyadh. A lot of trees. I think one of the major goal of planting 6 million trees in Riyadh by the year of 2030. I would like to talk about King Salman Park because we are the one who put the master design of it. King Salman Park, if you look at it from a bigger perspective, it's like the courtyard of Riyadh city. This is the lung, will be the lung of people lives in Riyadh after completed, after it will be completed within 2-3 years. They are saying it will attract most of the people living in Riyadh. It will participate in dropping the temperature of Riyadh about 2 degrees. This is huge compared to the other parks around the world. To live, go back to your question, Doctor, to live more healthy, more happy, I think you should go outside. You should look forward to mix with the nature, with trees, with air, with water, even with dust. There's nothing wrong with that.
I'll make just a quick comment on that. We have a problem of a sense of responsibility. You know the problem when I go out from my house, the paving is belonging to Baladia, so I have no intervention on this. Even the asphalt everywhere is a responsibility of Baladia to maintain and to go on, which is wrong. But believe me, within maybe the housing cluster, whatever, and when we feel that my children goes out and they enjoy the environment around, and then if we gonna call for something that we need, people will participate even financially. So it's the problem that about, make it that close to people. Let people, when they want to make help or help themselves by adding some elements that they can contribute and they can spend on that. All right.
Let me just add one small point, and I think it relates to the study you made last.
Yes, please.
And that is about mosques. And it was in his study that he mentioned that mosques should open up to nature, to all the elements of nature. And if you want to seclude one part just to keep it pure and clean from any kind of waste, you can do that, but at the same time, don't avoid the sky, don't avoid greenery, don't avoid all the natural elements that bring happiness to the person who is praying. The same goes for the house, the same goes for the office, for everything. So this supports what you were saying and supports, again, the point that you mentioned about healthy environments and opening up to nature and socializing amid nature.
Yeah.
Thank you.
Ray, there is the other point. Is there a possibility that we can inspire creativity and innovation in design? I'll make it a little clearer. I mean, sometimes when you go out, if things are very normal, common, it doesn't inspire you. Is there a way that I can let people, when they are in their environment, say, wow, how come this? Can we do furthermore? Or, I mean, it's quite important to promote people and to create a dialogue, how this is done and what we can do more further. There is points, maybe, I hope, if you can give thoughts about it. How can we create environment that inspire for innovation and creativity?
Can I?
Yeah, go ahead.
Go ahead.
Yeah.
Okay.
Go ahead.
As I was seeing the exhibition, and I found out that there was one of the pavilions that had glass that you can change from transparent to opaque.
Yep.
And this has been there for maybe the last 10 years or something. But the thing is that, by the way, this is very useful. Let me add this also, not only on facades, but even at home. Because sometimes you need everything to be opaque, but then those people who have dementia and don't remember where they put things, they want everything to be transparent to see where they put the things. So this is one way where it can be used well. But coming back to the facade, I was thinking and this is maybe an innovative idea, if we can partly make it transparent and make designs of opacity such that at the end you can see through the facade, but at the same time have parts of it opaque, even with designs.
Yeah.
That's one idea that came to me. But let me tell you one more thing, and I think it may also be there. When we were talking about the sun and the glass, and that sometimes we have films that we can put on the glass such that we can generate energy from the sun. And I was thinking, which facade would do that well? And of course, you know that the sun is always moving. So is it possible to just have glass panels that move with the sun such that it can be exposed to the sun for the maximum number of hours to generate electricity? These are two ideas of my mind.
Yeah.
For me, I would make it very simple of thinking in this way. Usually, we've been inspired by the nature. So if you want to draw a paint or something, you go to the lake or something. So from the nature itself, you can inspire, you can create. So just make your project or urban design or building similar to the environment. Make it to be inspired. So let's work with environment, not against. Let's be open with it. Let's our project, urban design, part of the nature of the city. Then I believe this will innovate the creativity.
Okay, on a project, I will continue furthermore. In a project like King Khalid University, it's a mega project. It was a winner project by us, and I participated in this. The question was, how can you create innovation and creativity, and how can you inspire students? And I said, there's two parts. There is literature part, that when you relate them to nature, as you mentioned, then they can write poems, and they can whatever. It could be imaginative. And the other side, that we can have scientific puzzles that could be within even the elevation or maybe within the landscape, and then somebody else will say, oh, I know how it's done. And I can tell you how it is built. And so it enhances and stimulate for such things, and it will make people always thinking with new, innovative thoughts. Because I'm worried about the time. Sorry.
No, it's okay. I just would like to add a kind of a brief statement. I think, all right, I totally agree with everyone here.
Yeah, please.
But I think it's also important to establish kind of a research center in the region, in area. Our region is different than other region. We have an arid zone. We have hot climate, as we mentioned. All of us agreed about that. Temperature sometimes reached up to 60 degrees during summertime, either here or in the Gulf. So I think it's worthwhile to consider kind of a research center to explore more material. We shouldn't stuck only of the material right now, currently used right now, glass, concrete, steel, aluminum, tensile structure. So why we can't create a new material? Why we can't come up with a new material could actually support us and help us in this part of the world to be more creative. They are doing research center in States, they are doing research center in Europe, in China, in Brazil, for their own environment to come up with different material. Do you think now, currently, those materials, I can count them in one hand, those are the limits of the material? This is the maximum we can come up with? I don't think so. They did a kind of a micro research center in Riyadh, for instance, to come up with a new material mixed between mud and concrete. And they are building now Al-Bujeri right now in Riyadh. They are building small buildings using this material. This is a kind of a huge step toward the future. We should consider, as you mentioned, Dr. We should consider creativity and innovativity not only for us, for our children, and for our grandchildren, new generations. One day we will go, we will vanish.
Right.
So we should leave a kind of a good legacy to our new generation.
Sure. I'm just worried about time now. So maybe I'll go further quickly to the other. We talked about regulation and which is inhibiting design, and I wonder that in the past, you can't imagine that within that maybe we call strict people, if a man wanted to get his son in a house, I mean, have extension for him, he can ask his neighbor, can I do that? He say, yeah, why not? They share together and they make that, they call it mujabbab or that shading area. So he can add and he can modify. But within that strict regulation, you don't have any opportunity to develop. And you make people, they are all in prototype system, which is not true. So I mean, okay, this hopefully that we can call the authorities to understand how to give flexibility, yet they can control the major element that made them having this. So just to save the time, I'll go to another point, maybe very quickly. Design for happiness.
We almost mentioned that.
Right, then it's covered. Now, let's go for the last one because of the time. Okay, adaptive reuse of the historic building. We have got a problem that in Jeddah, the most beautiful historic buildings catch fire, deteriorated. A lot of issues happen to that. And it is our responsibility to see how can we help this. So the floor is open for you before we close. What can we do with the historic building after we got bad experience of deterioration and demolition and fire catch problems? I think maybe.
Okay.
Yeah, we have 14 minutes.
I'll just quickly say something. I remember there was one historic building which I tried to intervene by rehabilitating parts of it because I didn't take full permission to work on that building. And I felt that new materials were not, I mean, it was against regulations to use new materials completely. And that was in Cairo sometime not far back. But then there is a project that I would like to mention, and this is by Ayman Khalil. He's a young architect who tried to make 2 post offices in Cairo. And because of the inhibition of don't use new materials, he tried to even scratch the wearing plastering from the stone such that the stone would appear much better than the bad plastering. But again, at one point, he used glass very eloquently in places where he let light in and he made the place feel much wider than how it was before. And I just really commend him for that.
I'll just mention very quick one. I totally agree with you, Doctor. We have to be very sensitive when it comes to historical buildings, and we have to deal with it in a very sensitive and respected way. We could use modern material, but in a way that we merge it with the existing material on site, restore it, try to use the same material of the building itself in a different way. Just try to be more sensitive when it comes to a historical building.
If I will say something about this point, is my belief for the historic building, it's not about the walls, not about the material, not about the age of this building. I believe it can be back by make it live by keep it with the people. Let's people back to this historical building. Yeah. Let it used again, so it can be adopted, it can be useful for the new generation, new use. Then by this, we can say, yes, we have historical building be used. Otherwise, if it's a maintain of walls, sometimes, someday, it will be gone.
That's great. That's great. So I may say thank you for all these ideas, and we hope that can maybe give hope to go with modernity and authenticate the modernity to be part of our sense of belonging and identity. And thank you very much, all of you.
Thank you. Thank you, Doctor, and thank you, everyone.
Right. So, yes. So, as Bart said, I think we had an interesting set of presentations today. Thank you all for those who contributed, and thank you all for being present in person. And also, I'd like to thank our event host. A round of applause for Bart. I think he was great. Thank you, Bart, for your time. So we've recorded this event. We will share the presentations. We'll share a YouTube link which has today's recording in a week's time, along with a feedback form. Please do share the same with you. And inshallah, we hope to return with the event once again next year, more or less the same time, and look forward to hosting you all. So thank you all. Can I call Thomas Fruhmann on stage, please? We'll have the mementos with our panelists, and we've got tea, coffee, snacks, and networking for the next half an hour, 45 minutes. So looking forward to seeing you all next year, inshallah. Take care. Assalamu alaikum.